All right, so now it's easy. So we need the project to exist somewhere. We need to tell people about it. We have to start making releases, maybe. We're probably going to get bug reports. I don't want them, but people are probably going to want to send them. And more importantly, users need a way to complain, because everyone does that. So this gets into the harder part of a software project, which is the community aspect. So when you're making an open source project, yeah, you can just post code out there, but if you're not working to get the community on board, it might go unnoticed, and this does happen. So when you're working on this, yeah, you need to have an actual structure around the project. In this case, it's software, so your typical directory layout and stuff like that. Pick a license. I chose GitHub to put it there just because we had other projects there and were established. So that helps with visibility. Also, start demonstrating the workflow you want contributors to do. So it's really easy if you create a project on GitHub and you want other people to contribute. Well, if you own the project, you can just push things to it. But try to get out of that habit. Instead, fork the repo and send yourself pull requests and review them and kind of play by your own rules. It might seem silly, but that helps paint that picture of how you want collaboration to work. I set up Copper repos so that we could get automated builds. So all those tests, people would send stuff. That was all the mechanics to get things happening, but I still need people to actually start contributing. And this is where you got to go out and start talking about the project. You need to, anytime someone's talking about RPM diff or asking a question, what is this thing about rpminspect? I've never heard of it. It's easy to get frustrated when you're working on a project. You're like, how can someone not know about this? I've been talking about it. Well, the fact of the matter is we all get a lot of email. There's a lot going on. We can't be aware of every single project. So instead, you can view those as opportunities to explain to people what's going on and how what you're doing, you're trying to save them time and make their life easier. So that's what I did for a couple of years. Is every time something would come up, I would say well, here's what I'm doing here. Oftentimes people would be really receptive to that. Thanks for explaining it. And then that would lead to them contributing either ideas or patches, and it just kind of grew from there. My manager did ask me to reach out to SUSE early on to see if they were interested in collaborating with rpminspect since they use RPM, and that was a very short conversation. They were absolutely 100% not interested. So I was like, okay, well, I tried. It was an odd conversation. I did try again about a year later, and they were still 100% not interested. So maybe that will change at some point in the future. But yeah, just being aware and communicating. You start to sound like you're repeating yourself, and you really are, because not everyone is going to see all of those conversations. You're going to respond in bug reports. You're going to respond on mailing lists. You're going to use events like this to communicate, kind of give the same presentation over and over again. But that's how we learn about projects, and that's how you start getting people interested in participating and contributing. And it takes a lot of work. I say it's harder than the code, and it really is. And like I said, eventually you start getting people aware and they start sending pull requests. I had some surprises to me. The Java maintainers at Red Hat were really interested in improving stuff in rpminspect, and I started getting pull requests from them. That was really kind of cool. The Anicheck and libabigail maintainers on the tools team were also really interested and receptive to bug reports and things like that. They even turned Anicheck into libanicheck and gave it a public API, which was really nice. So you don't know what's going to happen until you keep communicating that. And kind of going hand in hand is marketing. This is something I'm really bad at. And it ties into that community aspect there. And to me, this is really the hardest part. I know that I could be doing a better job of marketing this software and making the project known to more people. I'm just really bad at that. I would rather stare at a core dump file than go and figure out how to make people aware of software. So this is always an area that I'm looking for help with and just ideas on how to improve it. I said I go and monitor mailing lists and bug reports and just have those individual conversations. Those are easier for me, but other projects may find it easier to do presentations, do YouTube recordings, something like that. I don't know. It really varies by project. Now, I've been working on this for a long time. It's largely in maintenance mode. It's stable, but there's still stuff to do. Documentation, number one on the list here. There's been a request, this actually came up in 2019, which was be able to extend rpminspect with Python plugins, which I think is really cool. I have a branch that I'm working on that on, but it's not required. And just kind of going through the other RFEs and stuff like that. So it's, you know, it's just at this point, I think it's going to evolve and kind of live in maintenance mode, you know, until such time as something else comes along and replaces it. All right, so yeah, summary. So what did I do that I count as a win? And I gave these little subtitles here because I thought I would get some laughs, but you know, it's a tough crowd. All right, so the first was it's a library. So I decided to implement the core functionality in this program. I said it's a command line program, but I shifted all that into a library. And the reason is I feel like down the road there might be a need to, or it might be a desire to use that functionality, but have a different execution front end. So by splitting this out into a library, I'm trying to kind of prepare for that possibility. The vendor data packages, this was separating out the data from the code. And there's rpminspect data Fedora, rpminspect data CentOS, and rpminspect data Red Hat. And all those packages contain the rules. So when you run rpminspect, you run it according to a set of vendor rules. The biggest thing there is all of that's out of the code, and more importantly, I don't have to own it. So that's information that can be owned by the vendor and maintained separately than the program. We're doing that now for Red Hat. Fedora and CentOS, I still kind of have a hand in maintaining those packages, but there are people that also help with that. The last one here, I chose C as the implementation language. This is where I thought people would laugh, but there's a reason for that. Is the core functionality here relies on librpm, which is in C. The development and debugging tools for C are more mature than other languages. While I would have loved to explore something like Rust or another language for this project, the fact of the matter is I needed it to be done fast and be reliable and stable, and I know C well, and I don't know those languages. So I didn't want to tack on, oh, I should also play around with another language. So I get the advantage of being able to use all these other libraries that exist in C, and I can also keep the program itself really small. All right, so fails. Documentation. So like everyone, I am saving the documentation until it's done and stable, so that means it'll never be written. What I should have been doing is the same thing I was requiring with code commits, which is I would also write the test cases that would go along with the code commits. I should have also done the documentation, the inline documentation, so that I could be doing that all along. I made that mistake of saying like, well, I might refactor the API a bit, so why would I write the documentation for this if it's just going to change? But you know what? Who cares? You wrote the code. You're going to change that. Change documentation too. YAML, this is the thing I hate the most. I really wish I hadn't chosen YAML. It's a terrible config format. Initially, actually, I was using INI style files, but those are not. There's no standard for that, and they're not really flexible. I'm kind of stuck with YAML. Honestly, that's established. It's in dist-git now with rpminspect YAML files. So I do regret that. And then I had this idea as well for profiles in the config, which like really is just too complicated for people to understand. It was one of those like, oh, and I could also do this moments. So it's there, but no one really uses it. But that's just unnecessary code. I did mention INI style config files, and yeah, I changed that to YAML, and yeah, that was the only thing. Nothing else was wrong. Okay, so Things I still need to work on, yes. Command line option handling. If you're going to make a command line program, try to put some thought into the command line option handling. Don't just keep adding them. Like, it's easy for that to get out of hand. Look at tar, for instance, or now GNU LS, which is nearly impossible to remember options for that. I could have better debugging output and logging. And the -K option, so rpminspect will go and fetch builds out of Koji and all the RPMs. The -K option was to keep the builds, but the way that's implemented is kind of backwards from what every user was expecting. But to change that now, I need to do some better marketing and communication before I just drop that change on everyone. So the fix itself is easy, but I need to think about the communication around that. So that's why I have not done that yet. Successful collaboration. So yeah, Anacheck. So Anacheck is a command. If you've used it at all from the Anabin project, it's actually really kind of cool. But it was just a command line tool, and Nick had not implemented a library, and I said it would really be useful if I had this as a library. And he said, "Oh, I can do that real quick. That's super easy." So over a weekend, he just turned it into a library, but it needed a lot of work. So the API was a bit haphazard and lacking, and I said, you don't have this, you don't have this, you redefined 0 here and all this, and it was kind of funny, but he was really receptive to that. So now Anacheck has a library, which is really kind of cool. libabigail does have a library, but it's written in C++, and so there's problems there. But it was nice that this collaboration with Anacheck was well received. People also started submitting lots of GitHub actions for CI jobs. So if you go and look at the CI jobs for rpminspect, it covers many distributions. All the Fedoras, CentOS, CentOS Stream, RHEL is in there, Debian, Ubuntu, SUSE, Alpine, Arch, Gentoo, Alma Linux, and I added FreeBSD just for fun. I was like, can we do that? You know, I tried NetBSD and failed at that, and Mac OS 10, I haven't gotten that working. But this is just, you know, people saw that it was possible to start doing that and have been contributing things for that. So more coverage is always welcome. And also, a project should be fun. And I had one developer submit a pull request that really fixed up the parser, refactored that a whole lot, which I hated the YAML parsing code that I had. And so he extended it to support JSON and DSON. And if you're familiar with DogeScript, DSON is the JSON equivalent for that. So rpminspect does support that. And we get config files that look like this now, which is really kind of fun. And this does work. You can add this in dist-git. This is from Grub 2, by the way. So I just really, I don't know, I just think it's fun. Like, someone's going to come along and read this and think, what is going on? But yeah, this is just the kind of fun stuff you can do with contributions when you communicate it out and stuff like that. So I kind of ran through everything really quickly because I wanted to leave time for questions, because questions are always fun. So does anyone have any questions? Please have some questions.
You mentioned various distros. Yeah, are they actually using rpminspect or like?
I'm sorry, who?
Oh, you said all these CI jobs for different distros, but are they actually using rpminspect for some of the processes?
No. So those projects, to my knowledge, are not using rpminspect. They were just added to see if we could run rpminspect in those environments and if it would pass the test suite. Yeah, to my knowledge, no one other than Fedora, CentOS, and RHEL are using rpminspect right now. No.
So, as one who had to use rpmdiv in the past,
yeah,
the one thing that rpmdiv gave you is the interactive ability to react to the results, which is missing in RPM inspect because of the nature of RPM inspect being basically a batch run. Do you foresee any improvements in RPM inspect other than basically disabling individual checks?
So when you talk about the RPM diff reactions, you mean like the ability to waive a result?
Right.
Yeah.
Yeah.
So good question. So the intent with RPM inspect is to handle those wave actions that you would do in RPM diff through a local project configuration file. So yes, in this example here, you can see entire inspections are turned off because they don't really apply to Grub 2. But in an instance where the control given to you in the config file is insufficient, I want to treat that as a bug and say, okay, we need more fine-grained control for the rules in RPM inspect config files. Now, in some cases, that wave action actually needs to be handled through the vendor data package with a global rule. And that is kind of a thing that's not totally obvious, and I want to improve how that at least is documented and communicated. But that's actually the intent through RPM inspect, is you see the result that way, you modify the config file, and then it'll run again. There's no plan right now to implement like a reaction interface type thing where you wave it that way. That hasn't been brought up.
Yeah, perfect. Well, thank you very much. We appreciate it.
Thank you, everyone. Thanks for coming to my talk, and I hope to see you around.
The next talks are available and starting right now, so if you're switching rooms or anywhere, but we'll get started here in just a few moments. So. You all here or continue to be here for the We Build on the Success of Fedora Next track. Up next here, we are going to do a roundtable discussion of packaging issues for modern language ecosystems. And I'm happy today to present Jens Petersen, who's an engineering manager at Red Hat. So I'll hand it over to you. Thank you.
Yeah, welcome. So actually, the idea was that this should be kind of more like a roundtable kind of discussion. I guess we'll have to see how that works out. So yeah, so this is an interesting talk in the sense that, in the sense that it depends a lot on you what comes out of the talk. So I don't have all the questions or all the answers or anything. But I prepared a few slides to kind of set some context. So I hope helps. Also the title is probably a little bit off. I mean, it's not, the scope isn't just packaging issues or sort of, it's more about how SIGs operate and workflows and processes and, well, packaging issues. Right, so, can use this. Yeah, so I just wrote down these sort of, these are very rough numbers. They're not, you should take them all with a grain of salt. They're just, I just generated these with this Fedora tool. So it's just roughly the sort of rough sizes of some of the different language ecosystems packaged in Fedora. And they're probably a bit off. I suspect they're probably more Python than Perl, but anyway, just by this, I think some of the Python packages are a bit inconsistently named. But anyway, you can see that, at the top are Perl and Python, and then there's Rust and Golang, and then it's sort of, there's some PHP and Haskell, Ruby, and so this is fine. I mean, I guess the thing is, although these numbers look very big, in a sense, some of these ecosystems are absolutely huge, so in a sense, we're only capturing a very small fraction of, well, obviously we can't package every single little package in Fedora, but there's sort of a pretty big gap there in some sense. But maybe this is good enough, at least it's a good starting point. And I think we'll come back to this issue a little bit later, because, there's some, I don't know how to use this. Okay. Okay. But also, you notice that there's some pretty glaring omissions in that list. For example, the JavaScript is not there. I think we know that so a lot of the Node packages disappeared a few years back from Fedora, for better or worse. Also, Java is another very big system which is almost completely absent. I mean, obviously we have Java and Fedora, but not really packages much. But I'm a bit curious about who's here. So, is anyone particularly involved in any language SIGs, or to a lesser or greater degree, or not really? Okay.
I'm fairly involved into the Golang one,
Golang.
the local Golang issue.
Okay, great. Cool. Anyone else?
So I am involved in the Rust SIG, but I used to be more in the past. I kind of, not in the last months, but a bit.
Cool. Great, thanks. Anyone else? No.
So I'm not involved in any of the SIGs, at least language SIGs, but I do maintain a number of packages written in different languages, and in particular in JavaScript, because I maintain a couple of Firefox extensions. And I don't have the time, but I'd love to have a, best practices document for packaging JavaScript like we do for Python and Golang and so on. So somebody help me. I guess I wanted to say.
Cool.
I'll just echo that. I'm not involved in any of the language SIGs, but we have an infra SIG for infrastructure packages. and I maintain, I don't know, 250 packages or something like that. So any of the kind of solutions or broad tools for languages could very well apply to that sort of thing, and that's what I'm hoping
Right.
for.
Great.
You know, just better ways to maintain stuff or handle it.
Absolutely. Yeah.
Since everyone is presenting,
Please.
I'm here since I recently tried to package my first Golang package and realized the complexities. And it got sidetracked, so it's on hide, but I'll get back to it.
Cool. Yeah, and I'm pretty involved in the Haskell. I guess SIG, well, it's a very small SIG. It's mostly me and one or two people. But all right, let's keep moving because I want to sort of get more into the discussions. So yeah, I just noted down a few of the current changes for Fedora 39. I think there's probably more things happening, but these are the changes I could see, like Perl and Python. I think we all saw the big sort of Perl rebuild for 3.12, which was, I guess it went reasonably well from my distant perspective. And yeah, there's this change to remove all the Golang leaves, which I don't know. Does anyone know anything about that? Or maybe not. And yeah, I have a change for Haskell, which is getting ready. I don't know, I just put this slide in because I thought it's kind of interesting just to think about the priorities of SIGs and how they fit in with the Fedora values. Like, I mean, one thing I really need in the Fedora, in the Haskell SIG is more people, so like friends, and yeah, I've struggled with this over time getting, we have a real lack of manpower, so like, yeah, it's really hard to get package reviews done even because, yeah. Anyway, and maybe some of the new ideas like the review swaps, like on Discourse or so on, may help. And then there's the first, like, yeah, and I think like Fedora maybe was one of the first distros to adopt Python 3.12, for example. Yeah. And freedom, maybe it ties in with licensing, and yeah, so. All right. Does anyone have any comments on this? Or as I move on? Oh, yeah.
Maybe a story. I was working on compatibility with Python 3.12, and like for 3 different patches, I had replies from upstream. But where did you get Python 3.12 and NumPy working with it? It doesn't work with NumPy 3.12 yet. Exactly, that was my answer.
Right. Yeah, I mean, I don't know, this is a little interlude. I wanted to sort of probe people what kind of problems they're seeing or what kind of pain points, things to think about. And
So from the Go perspective, I see a very big process issue or tooling issue, whatever you want to put it, because the problem is that we have roughly 2,000 packages for 200 applications that we really care about, and then 1.8 thousand packages just because of how RPM works and how we decided to package RPM packages within Fedora, which would mean that if we can change that process or change the tooling to allow a different process, we can immediately have 1/10 of the packages and therefore way more manpower per package. So in our case, I think it's more a process or tooling issue more than a manpower issue.
mm-hmm.
So one way to approach this would be to automatize the management of packages, right? I keep the packages as a step and build on top of this. Does this sound feasible?
So we do have Go to RPM, which really helps in creating RPM packages. There are a couple of issues, though. The first one is that even with Go to RPM, we don't have a perfect spec file. So it's a very good starting point. Don't get me wrong on this, but it's not perfect. So it's not something you can completely automate. You should still doing the reviews. You should first reread your spec file, fix eventual issues, apply for the review, do the review and everything else. And the other big problem is that due to the Go and Rust have this fact that basically they create a static binary. So we only use 90% of the packages just for the sources, not for any intermediate things, which means that if we change one source package, one of those library packages, we don't have any real effect on the binaries that have already been built. So we should re-kick builds and builds and builds, which we don't do. Let's be frank, which means that a lot of times we do have bugs that should be fixed but are not fixed in our binaries because we have not done the rebuild. The big problem is that we have some packages that are we have 2,000 packages depending on those, and if we have a new version of the library, of the core library, and we kick 2,000 packages every few days, I don't think Koji would be happy with that. But aside from that, there is also a discoverability issue and that kind of things, as well as conflicting library versions. So a lot of times we end up having multiple source packages for the same library for different versions just because we have applications that we care about, are the only things that we really care about that are depending on different versions. Obviously, we can work around this, and we have done this for the last, I don't know, 5-6 years. But I don't think is a very good way of handling this kind of thing. And I think that if we are able to change processes or tools, then we can be way more efficient at doing this.
Yeah, that's interesting. Maybe I could. This is probably a bit special, but in Haskell, we have a kind of a good situation where we actually have a kind of upstream source distribution called stackage. So what I'm doing in Fedora is basically just pulling down packages from stackage, and so there's a unique. So we only ship one version of a library, basically, and all those packages are kind of supposed to be compatible with each other. Well, there are some exceptions. There are some packages in Fedora which are not in stackage, but largely that works fairly well. But yeah, I also don't know of any other language ecosystems which have such a distribution. Maybe there are some, but yeah. Which one?
LaTeX. I mean, it's not a language,
okay,
but
right.
they do have a big distribution that we then
life.
repackage the whole thing. So,
True.
yeah. But I think that the interesting part is that some of those languages have some kind of issues, others have very different kind of issues. So, for instance, Python have issues because obviously there are a billion Python packages. But the good part for them is that since everything is on runtime compiled, or at least interpreted, as long as, I mean, I think the current model kind of works for Python. Maybe better tooling can help with a bunch of things. Obviously, they do have problems with supporting multiple versions of Python and other kind of things like this. But others like Go and Rust have very specific issues due to their static nature rather than the others that have other kind of issues.
Right. You mentioned the need to rebuild, that you need to rebuild your binaries to get updated library fixes in. Yeah.
Yeah. So the issue is that in Go, for instance, let's say you have a binary that depends on 10 libraries. It will be statically compiled so that basically you have one binary that at runtime depends on 0 library, if not libc and a couple of very basic libraries. So that means that those libraries, even though maybe in RPM packages are splitted in different packages because we package every library in a different RPM package. In the reality, in the binary RPM packages, we only have one binary file in the leaf package. All the other packages are there just to make Koji or the builder happy. They are not there for the user.
Right. But yeah. So, I mean, like, you can sort of go to the extreme like the Rust has done in Fedora, where they only ship source, in a sense, source, all the libraries are only available as sources, and then you can build something using those sources. I mean, yeah. I mean, maybe it's pragmatic, I guess. I don't know. I can't say I like it, but I mean, my dream is that users should actually be using these packages, but maybe it's an unrealistic dream. I don't know these days. Yeah.
So a quick comment on that, that for users, those packages are completely useless. They're only useful for building other packages. So, I mean, it's a complex problem, but I wanted to make a comment earlier about the stuff that you mentioned, that the initially generated spec file needs adjustments. And for Rust, I think we're very close to having like 99% of packages generated either ideally or generated in a way where the changes made by the packager after the fact can be propagated. And I mean, either through an explicit patch or through metadata that gets applied when the generation happens. So it's like you apply some switches when generating the spec file, and those switches are saved to a config file, and then this is in this Git, and when you regenerate the spec file from scratch, you don't do anything. And I think that this is a good model because this allows automation to happen. And I can kind of imagine a situation where if this is automated and this can happen fully automatically, we could, for example, have, I don't know, pull requests in this Git in Azure that do the whole thing, and then it's a small step to automate or to allow anybody to do rebuilds in some fashion that doesn't require proven packager privileges. Because I think that part of the problem is that we have I mean, doing stuff in Fedora, if you're not a proven packager, in those ecosystems, it's just impossible. In other ecosystems, it's okay, but there you just need to write to 100 packages at any given time, and yeah. And we could solve this. I mean, I'm not sure if this is the solution, but we could adjust our permission models to allow this.
So the way we solved the permission problem was with creating the Golang SIG, assigning, but we have also amended, well, proposed, and then it got accepted, a rule so that every Golang package has to have the Golang SIG as a committer. So we are working around this. But my frustration with this is that, as you were saying, all those source packages have zero value for the users. Between Rust and Go, we are shipping, I don't know, 3,000–4,000 packages that have zero value for the user. We are just cluttering repos, the metadata of the repos, everything else, just because we want to apply a process that does not fit for these kind of things. Or like the permission, the Golang SIG permission on everything, which basically is a proven packager. Because if you have access to, I don't know, 10% of the whole repository, it's basically a proven packager level, which, by the way, is granted just adding a comment, being a packager, and adding a comment into a ticket. You get straight away access to a couple thousand packages, which probably is not ideal either. But all those are workaround because the system does not apply for those packages. So that's why I'm saying that I think that we should try to think also a different process that would apply for those languages, because at the moment it's Go and Rust, but I foresee in the future many other languages having very similar issues. Because I think that if we decide ways, or if we have tools to introspect packages, so that we can introspect packages after the fact, in a way that we don't have to have all those source packages, but only the leaf ones, then everything becomes easier. And another issue that I see is that, let's say a new contributor wants to package, whatever interesting tool they are using, they might discover that they need to package 50 packages and have 50 reviews, which then becomes a huge burden on the reviewers. Obviously, it's way easier to review Golang things than maybe other kind of packages, but still, it's a lot of work just because we want to apply a process that does not apply. So I think that we should really think through the process and see if we can just do binaries with vendor stuff, basically, because that would be, I think, the optimal situation, and then have tools to then be able to discover those vendor libraries and then do, for instance, free builds and that kind of things based on those metadata.
So I think that in the case of the 50 dependencies that you mentioned, there's two parts to the review of the dependencies, right? One is like the mechanistic packaging of dependencies so that they get dropped into the build route so that you can then use them. And I think it's like this most visible part. But there is also the review of licensing and I don't know, just a general review of the stuff that happens. And so the second part is actually useful, and I think that we want to keep it. The first part is just a technical detail that we could get rid of. So I think that the question needs to be, how can we keep the quality control over the dependencies that we have right now without this extra process that is complicating life for people. And I mean, I think that we shouldn't concentrate on the package part, because with automation this could be simplified quite a bit. Like, I can imagine a script where you're you're in the Golang SIG and you press do some invocation and it adjusts 50 different packages in a way that you can review and push at once, and we could make this happen. I think it would be important to figure out how do we deal with the licensing issues and the introspection of the dependencies if we change the process.
Thanks. So at least in Go, defining understanding the license, it's deterministic in the sense that, for instance, the Golang documentation gives you the license of every package you look the documentation for. So effectively, there are ways to extract this kind of information, and I totally agree with your point. There is value in the process, but I think that we can also get the value outside the process. So, for instance, let's say that we add one step into the CI/CD pipeline of Golang packages, adding one step that checks all the dependencies of all the libraries that gets vendored in, and if those are within a certain list of acceptable licenses, then it gets shipped. Otherwise, it gets blocked. I'm thinking something like this, and it can be, I guess, that in Rust you do have ways to discover a license, because I guess that your Rust 2 RPM or whatever it's called also does the same thing as well. So effectively, you could have a different step from the Golang one, because obviously you would have a different way to discover the license, but still be able to use the same idea behind it. but with different steps for different languages.
Yeah, but I think I kind of agree with Benny that having purely automating the licensing is license checking is a bit tricky. I don't know. I don't know. Maybe it's, yeah. I mean, I agree with you for many purposes. Maybe it would work, but there are often cases where there are mistakes in packages, like the wrong license tag has been put in a package or things like that. So, yeah, it's a little bit on thin ice, I think, if it's completely automated. But I don't know. Yeah, I mean, it might be something that could explode. But, oh, sorry. I think I lost it again. Well, could you disable the screen lock? Yeah. Also, I just wanted to add I agree that in some sense all these libraries packages are kind of useless, but I mean, in a sense, not that users don't care about it. But that still makes me sad in a way, because I feel like as a distro we should be providing binaries. So, because there's actually a lot of wasted. In terms of like in terms of, global warming and so on, there's so much wastage of rebuilding and rebuilding binaries. For me, there's things like NICs and so on and caches where, there are caches of binaries and so on. So, I don't know. I feel ideally we should actually be making those binaries useful so that users would use them. That would be the ideal. Maybe it's ambitious or unrealistic, I don't know. But that would be my desire. That we actually had meaningful binaries that users could use. Yeah. Like if I build something in Haskell using the libraries which are packaged in Haskell, I can build something really fast, whereas if I build it with like the upstream tools or whatever, then it takes much longer to build them. So yeah, you look puzzled.
Yes, because it does not apply for Go and Rust.
Why doesn't it apply?
It does not apply to Go, at least, and I believe also Rust is the same way, because due to how the Go compiler works, it will always try to compile from sources. You cannot pre-ship, pre-build artifacts that it will be used. It will always start from all the sources of all of your application and all dependencies and dependencies of dependencies and so forth and so on. And because doing the Big Bang compilation, it will do optimization throughout code paths and that kind of things and exclude all the part of the libraries that will not be hated by your application and so on. So effectively, due to how the compiler works, what you are describing does not apply to Go. Now, we can argue on the dynamic of Go and the compiler itself, but that is how the language works. So either we fork the Go compiler, which I don't think we want to do, or we accept that Go does not work that way.
All right, I don't know. Yeah, I'm not so experienced with Go or Rust, but so even Rust doesn't cache builds locally for like.
No, it's this exactly like this. You have sources and you build from scratch, doing optimization of the whole thing at once. Essentially, link time, compile time and link time optimization. Okay.
Because like in Haskell, there's two tools, Cabal and Stack, and both of them cache, basically build. So if you build some library and then you build it again, it will use the same binaries, like to link two separate packages. It can do so. Anyway, let me see if I can move on. Yeah, well, this is kind of what we're already discussing in some sense, but there's various issues about. Okay, this was actually a different slide, but yeah, most users would tend to often use upstream and upstream, they might use the upstream binaries even for Rust and cargo and so on. So I don't know. I kind of see this as, well, I don't know. I mean, I don't know. From a distro point of view, it seems a bit problematic. I mean, it's sort of the next logical step, if you want. I mean, if you resign to not providing binaries, then why even bother using the distro compiler then? I mean, so I don't know. I still feel it's sort of a slippery slope in some sense. Yeah. But of course, we want to have some things packaged in Fedora, so maybe we have to do the minimal work or streamline. I agree with you completely that streamlining the processes, and maybe if we could even get it down to just like a license check or something like that, more or less, or that would be great, yeah. Because at the moment, it's still quite a big hurdle to get new packages in. Any thoughts on this stuff?
So, I mean, if users really prefer the upstream binaries, then this is probably because they were better for the users. And I think that if we are providing binaries which are, we think that they're good, but actually they don't have the, for example, they don't have certain features enabled because we haven't packaged some dependency, then it's not it doesn't benefit anybody. It's the users are getting the worst experience if they use the package. I mean, for me, when I can use a package, it's great because first of all, I have a reliable delivery method. Second, I have a reliable cleanup method, and I get updates. And yes, it makes sense to do packages when the packages are at least as good as the upstream stuff. So in particular for Rust, if we do the whole process correctly, the package, the code delivered by the distribution is going to be exactly the same as the upstream one, right? Because it's the same compiler, the same sources. It's a bit different in traditional systems where, like in C, where you have compilation flags and link flags and maybe some patches and a different version of the compiler. And this all means that if by the end, when you get to a end user program that links to 200 packages, the way that you build each of those packages matters, and then the result can be quite different. Here, I think that in particular for Rust, you just end up with something that's maybe not binary identical, but functionally should be exactly the same.
Maybe I should just actually, I'm not sure I was clear. I think I haven't written it very clear. What I meant is that people are using the upstream toolchain, not the end packages. I mean, in a sense.
Yeah, so you're using the upstream toolchain, and so let's say that you are a user and you get a new Fedora, and then you okay, now I want to use this program. I have to install cargo and do cargo compile this, and then a week later I have to remember to update it. Then this is a terrible user experience, right? The good user experience is that every few days you click update, and then everything updates, and you want to have the same thing.
Sure,
and for me, this is the value provided by the distribution.
Sure.
And I think that's what we should try to deliver, right? Like stuff compiled in the way that upstream would compile it, or maybe slightly better, just nicely delivered as packages so that you get automatism.
We should not miss a distinction here between your Go and Rust and, for example, other systems where we have where you include things like Python, where people do a root pip install of something and break DNF is a prime example of where it goes wrong, because you actually use the dependencies on the system and can break one program because you want to install another program, which is not the case when you do it statically linking. So it gives different aspects of this particular problem. That's my point.
But I think it's actually a good example because we had this issue that users were doing pip install and breaking their systems, and we actually fixed it at the root, right? Because now pip install does not break the system, and we changed the way that we do things so that it's nicer for the users to use the upstream packaging if they want to. And I think that we need to do the same in other cases.
Yeah, I totally agree. And if we pick Go, for instance, the Fedora 39 change, where we dropped a bunch of leaf packages, those were packages, the must retire Golang leaves. Basically, those were all the packages that were source packages and were not strictly required to compile our binaries. Basically, we are saying we don't care about the users because the users will not care about all those packages. The reason why we have 2,000 packages, Golang packages within Fedora is just to have 200 binaries. That's the only thing we care. We care about Kubernetes, we care about etcd, GoPass, all the others. We do not care about Golang-Google-X-sys, because the reality is that the Go and Rust is the same. It's like those new languages are taught in a very different ways than C and the others were taught, where basically it was like, oh, we now have a compiler, we now have a standard library, we now have stuff. Let's give to the user the ownership of putting everything together. And in that world, distributions were great because they solved the issue for the user. We were able, as a distribution, to help the user. In those new tools, where basically the compiler also downloads all the dependencies automatically and compiles them for you, it's like the distribution has no space there.
Right.
So we either work with them and change the way they work, or we adopt to and accept the fact that users will not care about those packages.
What you said, of course, is true, but I would not agree that we shouldn't care about all the library packages that are our dependencies, or well, that are dependencies for the few hundred packages that we actually care about, because that's what people use. I still think there's some added value that the distribution can give. For example, with automation, this becomes tricky. There should be some gating still. Yeah, that's one of the things. We've got gating, so any updates that break other stuff should get caught.
They never break anything. Due to how the compiler works.
Okay, but when there is an upstream update, and I'm not that familiar with the Golang or Rust ecosystems, but I know you can pin dependencies onto a particular version, but does it always happen, or can you just say, I depend on version 1.5 up to whatever, but not newer than 2.0, for example, right? Yeah, you can specify them exactly, but also with the range, right?
Usually in Go you specify exactly, and then when we package it, basically the way we do is we remove that hard limit.
Yeah.
Sorry. Yeah, sorry. In Go, you have the specific version pinned, like 1.7.4-1, and then we do a little bit of trickery to make it work with slightly different versions. Otherwise, everything would break. But due to the way it would work upstream outside Fedora, it would be with very specific versions pinned.
Yeah, so what we're doing in Fedora is actually a bit different than what upstream is doing. But actually, upstream benefits from what we are doing because I think they do, because they know that if we encounter problems, they know that things will break when they do an update, right? So they need to react. I know you want to reply, but another benefit is that okay, I'll let you answer.
Thank you. So yes and no. First, because due to how the compilation works, upstream, let's say Hugo, for instance. Hugo is written in Go, they deliver a binary. They will only, upstream will only support issues on their binary. And if you go there and say, oh, I have this specific issue, and they are like, well, it does not apply to the binary with the right version of that library. So if you are on a wrong library, that's your problem. And they do have all their CI/CD for exactly those very tight versions. And we are trying to loosen a system where it's very tight upstream and everything works. We lose it, we break stuff, and it's our problem now. And the second issue is that often we are not we don't have libraries that are version higher than upstream. Upstream, at least in Go, a lot of upstreams, simply one time every week, they update every single library they have. So they are way more bleeding edge than we are. So we are just lagging behind. We are doing a huge amount of work for, I would argue, very limited benefits. If it was zero cost, okay, yeah, whatever, who cares? But since it has an impact, it has a cost, it has tons of hours of contributors that gets then demotivated from this, do we really want to have this?
Okay, so you're obviously working with different upstreams than I am, because, well, I maintain a very limited set of Golang packages, but when I get notifications from our release monitoring.org, and I check what the changes were, I don't always see, the dependencies updated. They're usually pinned to whatever version they were at when they were added for a very long time. So I think that's probably the disconnect between what you're seeing and what I'm seeing, and what I think Fedora value is here. So.
Yeah, maybe I'll continue a bit and we can see. There's only 10 minutes left. There's a few other topics I wanted to cover. I don't know, in the context of our current discussion, I'm not sure how well it fits in, but one is about package workflow. We talked a bit about the high barrier to entry of packages. So I'm wondering, what would it take to allow, to sort of really streamline this process of introducing new dependencies? I don't know what, because that would require some significant changes to package review process. Or, I mean, maybe it should be done in a sort of SIG specific way, because I don't know. I don't think we. I don't know. I'm not sure we can open up the floodgates to any package just being kind of just coming into Fedora just on the basis of license. So maybe SIGs would have to be involved in some kind of process around that.
I think that surely we can delegate stuff to SIGs. That could be an idea. Though there are many SIGs that will have the same issues. So personally, the way I think it would be best, it would be that if the Fedora project says, look, we have analyzed multiple options, and we have seen that there are three possible, let's say three or one, 2, 3, 4, 5, whatever number of possible models that can apply, you, SIG, can choose which one of those flows better fits your model. Sure. So that we don't have 20 different SIGs that everyone does different things or slightly different things, but still we do have a little bit more freedom on a SIG perspective. And another thing that I think we should really fix is that a SIG should be able to be the owner of a package, not individual contributor, not only individual contributors.
So I think that essentially we are using this Git metadata as a list of allowed dependencies for packages that are compiled from source, including all dependencies, right? So for us in Golang. And I think that we could switch to a model where the same information is kept in a different way. I think it would require like a discussion of how to do it, but essentially I can imagine some model where we have a list of, we don't actually package the dependencies, we just say, okay, well, you have the dependency foo, and we just allow, I don't know, either all versions of foo or versions of foo between this and that. And at compilation time, the package that specifies that it wants foo with a specific version on a specific range gets some version of the dependency delivered, and the compilation happens in exactly the same way it happens right now, because right, you get some version of the dependency delivered and you compile that. So if we do this via some different mechanism than through this Git, then I think that many things will become simpler. In particular, like pruning obsolete packages could mean that we don't prune stuff, they just stop being used and they don't bother anybody because there is, that's one thing. And this also solves the problem of different packages requiring slightly different versions, or even not slightly, but majorly different versions of the dependencies. It's, I mean, it would really simplify the life of those ecosystems if you could just use what the upstream says by default, maybe allow overriding this.
Very good ideas. Yeah, I like the way you're going with this. Yeah, I mean, if we really can have something of this in the future, that would be pretty exciting, and that would open a lot of possibilities, I think. All right. Yeah, I think we're running a bit short on time, but another topic I sort of wanted to touch, well, I don't know. I'm not sure if this is a good topic, but about RPM macros and I don't know, it's pretty hard to change RPM now because it's so ubiquitous in our operating system, but I don't know, I also feel that like the RPM macro language is pretty awful in many ways, but I guess it's sort of a worse is better kind of thing. I don't know, I kind of wish of some more modern declarative language, which, yeah, but I guess I'm dreaming, but maybe it's not really a, well, I don't know. I don't really need this to move forward. I think what we're just talking about now is probably the biggest problem that needs to be solved. But yeah, and then there's, I don't know, the things about like tooling and automation, and yeah, I was sort of hoping we could have some knowledge sharing of different tooling and automation around packaging, but we're also running short of time, so I don't know if anyone has anything they want to. Yeah. I know I think Golang is using dynamic build requires, which is interesting, yeah.
Yes, we are using both spec generator, dynamic build requires, but I really feel like we are trying to patch something just to make it work. Dynamic build requires, like, I'm not saying that invalidate everything because they don't, but it's such a workaround around a process that is very static. It's like the RPM process is very static by nature, and to make it kind of workable, then we put dynamic stuff into it so that it becomes kind of acceptable. And it's like, yes, it's true, but we have change the nature of that process itself. So at this point, I think that we should really think about like what was proposed as different dist-git builds or that kind of thing, so that basically it just flows the part that we really care about.
No. Yeah, it does feel like a bit of a hack. I don't know, but yeah, I mean, I guess it works. But yeah, I just mentioned sure my personal plugs here, but yeah. I mean, the other thing I noticed is like misalignment or between like the upstream and the distro. Well, I guess we've sort of talked about it a bit, but for example, I think Haskell is surprisingly well matched, maybe because some of the packaging, sort of distro packaging people were involved in the packaging system design originally. So it kind of maps pretty well, whereas, I don't know, maybe some other languages it seems more tricky. I don't know, maybe Python is almost the worst in some ways. I don't know, I'm not sure, but yeah. Anyway, we should probably start wrapping up. Yeah, I had a few other notes I made here, but yeah. I think someone brought up this idea about cascading rebuilds, automatic rebuilding. So I guess, yeah, I think that's what Nix sort of does, more or less. But another thing is that I'm seeing a lot of new languages which almost can't be packaged because they use such weird packaging. It's a real problem, I feel like. It seems like a lot of new projects don't really have this idea of being packaged into a distro. It's like an afterthought or something, which makes it a bit sad too. But yeah. Yeah. Oh, one other thing which is interesting, I think, is this cross-distro collaboration. I mean, we actually had in Haskell we had some collaboration with the OpenSUSE, which has been useful actually. We used to share a bit more tooling. Now they've slightly diverged. They're actually more bleeding edge than Fedora, but in Haskell. But yeah, so I think that's more or less what I was going to cover. But if anyone has any last ideas or thoughts or other things that we should think about in the future, I don't know.
So I think that, I mean, we didn't discuss this at all, but I think that we need to reinvigorate the packaging guidelines and packager documentation on the wiki and in the docs, because I mean, there are some parts that are being updated regularly, but many parts are just full of obsolete stuff. You had F-branch on one of the previous slides, and like if you're a new packager, I mean, how would you find out about those tools, right?
Yeah, I haven't been very good about publicizing it. Yeah, you're right.
And I'm not sure why this has happened, but I don't know. Like, we should really put work into updating the docs to just have the current stuff and get rid of the old stuff, or put it on the side somewhere where it doesn't confuse new packagers.
No.
Hello there. Can I just add something on that? A good way to get engagement in the community on that, if you can spot problems that need to be updated, can you create a ticket and add it as a good first bug or something? Because it might encourage people that don't know anything about this to jump in and try to fix it, you know?
Well, I mean, you don't need to do that. You open any page and you start reading it, and then you see like, okay, this is formatted incorrectly. This is, I mean, like if you do packaging, you essentially on any page you will have stuff that is. I mean, like I could open 100 tickets if I wanted to. I don't think it would make sense. I mean, I would just overwhelm the pipeline.
Also, I do believe that the RPM packaging guide is actually approved by FESCO for the changes. So I'm not entirely sure that that would be a good first change for someone. I mean, if it's like a documentation that is easy then to get your change merged, then okay. But if it's stuff that first could then have to wait in FPC, okay, but still.
All right. Yeah. Well, thank you very much. It was a good discussion. Enjoyed the session. Thanks for coming.
And we'll go ahead and break for lunch. So if you guys want to join, there's a lunchroom just down the hall. So if you go right out and to the left, and then the talks resume, I believe, at 1:30. So thank you all very much.
Okay, I'm David Duncan, and I work with a lot of other people on the cloud distribution or edition, and the focus of the cloud edition has been one of those things that in the past was was kind of slipping behind because we had Atomic. I have the jacket over here for Atomic for a long time, and then we thought that OS Tree would just really kind of just replace everything. And I think, you know, our 5-year plan includes the immutable OS as a big part of that cloud initiative. Obviously, that's the foundation for OpenShift. There's no way to get around that. That said, I work for Amazon, if you didn't know. And my role is to talk to customers who are using partner Linux and Linux-based solutions on top of cloud architecture. And so I hear about what's going on, what their pain points are, what the things are that they want to have at their fingertips beyond just their modernization models, right? A lot of them have solutions like SAP that run for, you know, upwards of 30 years, and their expectation is that they'll have a consistent experience for the duration of that time. Modernization doesn't really, we don't talk about modernization in terms of decades, right? Not at this point. We talk about servers as a you know, in terms of decades. And we're just starting to talk about our cloud solutions in ways that operate predictably. And so I pride myself and I pride the work that my team does on building solid support for Linux and Linux-based configurations on top of the cloud, right? Or as Peter would say, maybe somebody else's computer. The fun thing about that is that I have learned a lot of the paradigms, and learning a lot of those paradigms made it made me a ready fit for the Fedora experience and the cloud and the cloud team as Dusty Mabe was turning his focus towards Fedora CoreOS. After the acquisition of CoreOS, obviously, all bets were off in terms of Atomic. Atomic was retired, and that cloud experience started to accelerate around the CoreOS experience. And I have a great relationship with CoreOS. I love to work with the team, and I also enjoy running it for specific solutions. One of my favorites to use CoreOS for is running agent-based step functions in cloud environments, and that means you can create an environment that is basically throwaway. You know, just arrives for minutes, produces the artifact, and then is destroyed as a result of some sort of state function. Very much enjoy that. But today, I'm here to tell you that we put a lot of time and effort into reigniting cloud as an addition, and as a community, this was a really unifying experience. It also brought us to a place where we recognized that there were some different goals around cloud than there ever had been before. One of the things that we talked about a lot was the concepts around what is a cloud image, right? If it's not just exactly the same thing as the server image or maybe the workstation image, then what really is it? And some of those questions are answered in the way that we leverage the cloud configuration or the images themselves, because they become extremely versatile. We don't just create a raw disk file. We create a solution that is kind of a minimalized version where we know that we're using utilities that are consistent with the expectations that customers have, or users have, really. Users have in their, just in the breadth of their experience, right? So it doesn't boot differently than other, on one platform as it does another. The expectations are, we try to maintain those as consistent. Now, we are also trying to work with to increase the documentation, and that's another thing that, Peter's in the room, and I'm kind of excited about it because because like I have all these initiatives that probably land in things that he's governing at this point around cloud, and one of the things we need desperately is we need help with our documentation and integrating with the team to do better documentation. I know you are. I had someone who committed to it, but then he is a volunteer, and so we work on his time, as he's available, and then give him as much help as we possibly can.
Yeah, but we have reserved space on the homepage.
Excellent. I am grateful. So that also puts us in touch with the websites group, infrastructure on a fairly frequent basis, and it gives us a lot of initiatives around the cloud providers. For me, the goal with Fedora is to extend that functionality across any provider that is willing to work with us, right? And right now, we're putting a lot of time and effort into focusing on Azure and ensuring that Azure works. That has been kind of an up and down kind of experience, but in our last release, we've had to make a lot of security modifications. So if you haven't noticed, several of our change proposals that have gone through have been around like disabling support for non-tokenized communications with the metadata services, ensuring that we have support for faster network interfaces, and ensuring that we're getting the right kind of support for that in the configuration of the image creation. That said, our image creation is done using a terrible tool. A tool that was wonderful in the time that it was heavily maintained, but we have other options now, and I think that as we look to the future, we will see we'll start to use more Ansible rather than using additional code development for our DevOps. We decided that we would try to build our own collection, so we're sort of working through building a collection that will support our requirements for upload into Oracle, into Azure, into EC2, and into GCP. And we find that that's really where we want to be. So when you think about where cloud belongs, cloud kind of extends out into the experience of the Vagrant images. We have an expectation that we're going to extend that cloud image into the WSL. The work that we've done around leveraging Kiwi in the context of Koji has given us the option of creating our own WSL image that's consistent with the images that we're creating for the cloud providers. That will give us the option of kind of refilling that space. There are other people who are doing a great job of re-rolling the cloud packages and then placing that into the WSL directory, but we'd like to have our own. So I guess here we have a packaging strategy that we're just forming. And that is similar to the way that the NeuroFedora team has settled into their packaging model. We want to have several packages that are associated with things that are central to the cloud providers, all sort of centrally located inside of the cloud team. And the reason we want to do this is because we don't want any one person to have to be responsible for the packaging model or enduring making things work all by themselves. We'd like to have this be a collective where those packages that are necessary for, say, the Google Compute CLI, the AWS CLI, other types of tools like the cloud development kits that come from these groups, Cloud Shell integrations in the desktops. We want to make sure that all of those work and function in a way that is consistent, and that we have a unified voice in the way that we communicate back with them. If you haven't looked at some of those CLIs or the anybody who's worked with cloud will probably know that they've been bitten by the experience of having a cloud provider's utilities that are based around an earlier version of Python, like Python 2.7, in the modern world, and that gives us a lot of pain points for trying to integrate, and we want to have a unified voice on that. Other things that we run into is we have cloud providers that or developers who will constrain the requirements. So if they're using a Python-based CLI, that Python-based CLI may be leveraging some version of Pigments or some other package that is consistently lower than what we're producing for Fedora, and we have to go back in and relax those requirements. I mean, this is kind of a common thing in a lot of software, but it's something that we really don't want to do. We want to make sure that we have consistency across the board. And I do this with my, in my professional life, I do this try to do this across the board. But then here in Fedora, this is the unified voice that I want us to have, and make sure that we have that as a group. So that kind of gives you where it is that we see our strategy and where we see our position. So moving on to that, we also see the cloud being very much integral to the workstation experience. Obviously, a lot of our testing goes on in a server environment or in OpenQA in ways that is just sort of basic, and we want more advanced configurations. We want to look more at what the boot requirements are. If something fails in one of our cloud environments, we really want to take it back to a server that we own or workstation that we own, and take it through its paces to determine if there's something that we can locate there just as easily as we can trying to do debug with no serial console. So, I see us as sort of in line with the Fedora server model. The server model obviously has a lot of things that we don't need. So we don't require DNS. That's a service that's expected to be provided. We would maybe provide some sort of an intermediate, faster response, but we won't provide the full-fledged DNS support. We don't need DHCP, obviously, because there is already a DHCP provider. There's no way to get an IP address on any of the cloud providers without having your own DHCP assignment. Let's not talk about IPv6, though. And so, we try to keep that image minimal. But that said, there are lots of things that we can do. The IDE that I've put on here, and this is like an idea that I feel like we can flesh out more, is that most every cloud provider has some IDE model that they're using that is cloud-based, similar to the one, it's almost web-based, right? It's a web-based API or interface, like Cloud9. And the Cloud9 API sits on top of some instance somewhere. And today, that like the team that's responsible for it, they're responsible for, they publish instructions on how to make your own, but then they don't actually make one that is associated with Fedora. So I wholeheartedly believe that is something that we want to provide for our development engineers who are working in that space, who are interested in continuing to work in that space, and make sure that they have a segue or entryway into the Fedora community and our projects without having to change what they were doing previously, just introduce Fedora into their workflow. Kiwi with Koji is one of our big paths forward. And the reason for that, so we like OS build, and we like the way that it works. We love the way that it functions as a service. It has a very clear position inside of the community and our efforts. But right now, there are a lot of things about it that are that limit what we can produce, including the WSL images, including container-based images, including images that are associated with Azure in the way that that's expected. And so we want to ease our way into what's being done inside of the Fedora community, but we also want to introduce Kiwi because we think it's a very effective tool. It has a great way of layering the configs, and we can have a composable configuration that we can break down and not be responsible for everything. And that is one of the reasons that we've chosen it as a part of our process. And all of our tools, our current tools, are in maintenance phase. We're producing architectures for ARM and for x86-64, and we have special friends inside of the Red Hat teams who are producing S390X machine images for us, and then reporting back if there's any inconsistency in the way that those are functioning. So these are the architectures that we're supporting. I keep hounding the internal guys at EC2 to give us access to the Mac instances so that we can try out this Asahi stuff. And we're working on, we want to see as many customized images as we possibly can see. If there are things that people need in the context of a specific cloud provider, we want to make sure that we're capable of producing that, and that we have, in the context of these Kiwi configurations, a composable component that will allow us to make those, whatever minor tweak or major tweak that needs to be done for that specific environment. So let's say you have an ARM64 instance, and that ARM64 instance requires IOMMU be disabled, right? Because there's no, that caching layer is not actually there in the ARM architecture. It's only there in the Intel architecture, and accessing that cache can then add incredible latency to and context switches to your communications with the processor. And we want to make sure that those customized configurations are in fact included inside of those. The agents that are associated with Google compute platform versus the agents that are associated with Azure, we want to make sure that those are specifically addressed. But then we also want to make sure that we have a generic experience that customers or users can take advantage of in their process as well, because we don't want them to lose track. Again, we don't want them to lose track of the things that they've already developed and have to move to something different just because they've moved they've decided to use Fedora. So that's one of the reasons that we think Ignition is a great idea, but we don't want to forfeit Cloud Init, right? So the package dashboard integration is something that we're working on right now. A few of the packages that we're working on, including in that, are the hibernation agents for the EC2 instances, and then the Windows agent actually includes that same kind of hibernation. That one tends to be something that you wouldn't want to put anywhere else, right? Because they modify the sleep.sh files, and modifying the sleep.sh is kind of a no-no anywhere else. Like you wouldn't, Peter's not going to do that on server. And so, we have to make a conscious decision that this is something that's going to be beneficial outside of the main, our main distribution objectives. But that said, like making that decision doesn't mean that we immediately take the cloud provider off the hook. That means that we work with them upstream in the way that Fedora is supposed to, right? Which is we we go back to those service teams and say, guess what? You're modifying something that you should be pushing, your modifications should be pushed upstream, and people should consider these to be consistent with the way that you're supposed to handle that. So we want to make sure that we have that parity. So here's a few things that I am asking for. We need test plan updates. Like, we have lots of things that are not being tested as well as we wanted to. We need support for our Fedora Cloud Test Days. Fedora Cloud, if you're not familiar with the Cloud Test Days, these are wonderful things for us to get into, and it's a great place for us to have more automation. So some of you guys in here are from the Ansible group, and you may know a little bit more about automation and automation platforms, maybe. But we'd love to have your help in ensuring that a lot of those are ready for use and ready for testing, and we can get a lot of feedback very quickly. Btrfs, if you don't know, is an important part of our process, and this is something that separates. So you'll see the work on Enterprise Linux Next, and how that Enterprise Linux Next is kind of deviant from how the Fedora Cloud image looks, right? We have this base of Btrfs, similar to the way that Workstation does. And one of the things that we wanted to do here was to create an environment where we could really separate that experimentation and provide a lot more connection back to or feedback on things that might be beneficial far in the future, or even closer. But it gives us an opportunity to do some of that exploration. And one of the things that we want to do that is directly related to some of the objectives around in the Red Hat experience is to provide some microkernel models that people can experiment with. We need we need lots of documentation. I'm short on time, so I'm just going to say that right out loud. These are some of the things that I think would be great for us to have as companion guides, and to have as for more friendly documentation for each one of the cloud providers. And these are some of the things that we're doing. The Cloud9 integration. We're looking at doing NeuroFedora as a connected way, a connected image with the NVIDIA controller drivers already established. A lot of the cloud providers already have distribution rights, and we can produce images, and those images can then have the associated NVIDIA controller drivers integrated back in. And then we're also working on the workstation model, so VDI is another thing that we think is really important. We'd like to do some more of the integration with the HPC technologies like parallel cluster. We just really want to make things more flexible, more agile, bring more of this opportunity. We have another talk on Thursday about building your own images and how we build those images. And we really want to take this all the way out, right? Like this IoT experience can definitely be brought all the way back into your cloud experience, whether you're running it on top of your server or you're running it on top of a cloud provider. So with that, I'll take any questions you have. I appreciate your attention. There's a lot of attention in the room, and I appreciate that. Grateful. Any questions? Well, if you find that you have questions, you can find us here. I'm here all day. And always love to talk about it. The Cloud SIG meets every other Thursday. We meet on an early morning, so it's not a very APEC-friendly time zone, time frame. But happy to move that so that we can increase the amount of participation if we need to. All right. Oh. Probably got 20 seconds left.
No, I was just going to ask, so how did Amazon take your suggestions on how to fix the EC2 hibernation agent, you know, to make it more upstream friendly?
Honestly, they took it really well. There's a specific engineer who made his first kernel commits because I was collaborating with Dave Chenner on how we could make it work, and we had run into a bug, and it was an NVMe bug associated with XFS. And Dave and I were talking back and forth, and I said, you know, this guy Xiaoyi is working on this bug that's associated with this. Can you help him get this kernel commit done? And he literally, you know, coached. You know, we the two of us together coached him on making the commit, doing the work inside of the LKML, and then Dave took his patch. Like, there was, you know, obviously this was his first patch, so he took it with, you know, some spacing issues and tab space mixes, which probably wouldn't have happened if they hadn't already had the kind of behind the scenes conversation about what their goals were and how to attack it. But it made him a first time, you know, kernel committer, and that to me was like the, you know, experience of a lifetime, to say that, you know, this is EC2 hibernated agent, and the reason that this, you know, Xiaoyi is working with confidence on the kernel is because we had this conversation in the context of Fedora, and we had it with the owners of that code, who also happened to just so happen to work for Red Hat.
So cool.
Yeah. Well, I know I'm out of time, so I'm going to say that I appreciate everyone coming and listening. And if you want to participate, please let me know. And if you want to talk further about what we can do to make, you know, to streamline how I interact with the teams that you work on, really looking forward to doing that. For years, the way that we've done our uploads, but Image Factory really only supports one cloud. And if you look at it, the code is built around libcloud, and libcloud, if you don't have any, you know, if you don't have cloud experience that goes back to Joyent, right, which are the people who brought us NPM, and Node.js, they brought us all of that. Joyent was a company that was first on the scene, and Eucalyptus was there, and then libcloud was built. I think it was built by Matt Garnett. Matt Garnett was part of the libcloud team, and Matt went on to do the Bodo 3 libraries for Amazon, and he did those independently, and then Amazon said, you know, we'll take over the maintenance for that. We'll bring a whole team to it, and that's how the Bodo 3 library became Bodo 3 and Bodo Core and the AWS CLI. But the reason we wanted to do an Ansible collection is because libcloud was one of these things that people used as a result of wanting to do a generic experience, right? They wanted to create a generic experience around it. And libcloud was built around Eucalyptus, and Red Hat had an initiative when Joyent was nascent, and the concepts around Eucalyptus were still called distributed computing. And they had a program called Delta Cloud, which still exists, and libcloud is a component part of that Delta Cloud initiative. The Delta Cloud, all of that is based on 2.7, and of course it went into the Apache project and did what things do when they fall into the Apache project. And, but they have, I mean, there's still people who are maintaining it. It's great. They're just not making advances on it, right? So, and they don't fix a whole lot of the bugs. They just fix the ones that are critical to whatever it is they're doing. And our use of it never got beyond the AWS configuration. So we don't have any advanced support. There's clearly no support for the for Oracle, cloud infrastructure, and never will be. So we know that we have a mission there, which is to create that consistency. And the way that we thought was best integrated with the way we work is to leverage Ansible in the same way that infrastructure leverages Ansible, and that way we would have the ability to just push whatever into that Ansible playbook, and then the Ansible playbook could be responsible for the image creation. There are things inside of image registration that wouldn't necessarily lend themselves to that in like the Red Hat images, because Red Hat images have assigned billing codes and things like that that are kind of hidden behind the scenes, and we probably don't want to, like, they're so not useful. They're only useful to like three actual users of that, the image registration. So they would never be, it would never be a prioritized function. But it's something that we can use to build very specifically images that are leveraging the same kind of components that we have, both in the kickstarts and also in the cloud utility, in the image factory that we use today. They integrate really well with Koji. Make it super easy for us to do an event-driven architecture once we have a consistent image, and that image goes through test. Once the test promotion happens, we can automate the deployment based on that collection. The collection itself does some things that are not standard, so all the Ansible guys would kind of be like, yeah, that's a nice idea, but you're still taking a lot of requirements for other collections to make this happen. But I think we have a fairly good foundation for why it is that we're supporting additional collections in there, and leveraging collections that have some support today, right? So GCP, the Google Compute is a supported configuration for Ansible automation, and the same with the AWS, and we have some other things that are coming up in Azure, obviously. So that gets us our primaries, and then we can leverage some basic commands for some of the smaller providers, like more what they call managed clouds, right? Rather than the public clouds, the managed clouds where we want to make sure that we still have images on the managed clouds too, and this makes it possible for us to have more of a collaborative experience around that. So if you're looking at what I think is really important, for me, what's really important is making sure that we have this kind of distributed architecture that's easy to drive with event-driven experiences around the QA team's results. What else would you like to know about the cloud? So I'll get more into the cycle, I guess. Now that I realize I have more time, this is going to be more fun, actually. So one of the things that I got it. F5, nope. Okay, fine. I'll do it from here. Okay, I'm going back. So I'm going back here to this one. Okay, so this is kind of an exciting part for me, the Fedora Cloud for IDE. The reason that I think that this is kind of amazing is it represents a lot of things, ButterFS being one of them, right? This is totally deviant from what you would expect a cloud image, or I'm sorry, an image to do, right? Like if you were pulling together a spin right now, you probably wouldn't pull together a Cloud9 spin, right? And the reason for that, our ability to do that is because we can do a whole lot of this in post, right? So I can do this in ways that are consistent with whoever has the contract, right? So if I look at what happens in a service team at Amazon, they're required to use the EC2 image builder, and I can build a document that is just as easily leveraged inside of the EC2 image builder with Ansible as I could one that was used inside of the Ansible Automation Hub. And that way, if we have an event-driven architecture or a requirement for building something that has a zero-day exploit, we can literally roll that into a golden image pipeline. And the golden image pipeline can be associated with like producing all of those images. And that kind of is something that's really exciting to me. The images so if you're looking at that, you can think about it in terms of like characteristics of other service workloads. And my goal is to become consistent with the requirements that Steph Walters has around software as a service. So basically supporting a lot of the work that's being done on top of OpenShift and OKD in the community to identify how we can build software as a service. And one of the ones that, in fact, one of the guys that's on my team at Amazon has kind of adopted the concept of doing Pagure as a service. And to leverage that is one of our ways of producing a visible support for an application on top of the both the Fedora cloud experience and also the OpenShift experience. We don't want to muddy, like from a cloud perspective, I don't want to muddy the experience that customers, that users have around OpenShift and the experience around container-based workloads. I want to enhance that, and then where they have specific techniques or expertise to ensure that they have supplemental models for that. And then to provide these things like the Cloud IDE, where they would not have normally chosen to go to like Eclipse Che to do their work, right? They would have already, they would have been tinkering around with Amazon Linux under the hood or Ubuntu, and they think that this is a great fit, but they're really looking towards a RHEL architecture or infrastructure, and they want to know what that RHEL infrastructure is going to look like when they're doing that configuration. And then we can do things like, because we have this package maintenance group, we can take the package maintenance for things like the cloud development kits, and then take those cloud development kits back into those IDEs immediately, and then we can have sort of a point-in-time support model, so we know where our support exists, and then our customers can understand, or our users. Sorry, I keep saying customers because they're not customers; they are users, and our users are capable of making decisions that qualify their workloads in ways that they were already familiar with. So the strategy is meet them where they're living and where their technology exists. ButterFS, again, I'm jumping around a little bit. I'm sorry about that, but the ButterFS decision we made supports a lot of send receive models for snapshots and snapshotting, and obviously we could have chosen a much larger file system. But that's already kind of covered in a lot of the larger cloud providers, like the EFS utilities for the extended file systems, which uses NFS v4 to create parallel file storage across multiple availability zones. And we can take advantage of those EFS utilities to just mount that up on the instances themselves. And that's leveraged actually in a lot of the OpenShift configurations based on some of the stuff that we were doing in experimental work around Fedora. So Fedora Cloud. And the Butterfest, we've been looking at ways to modify so Kiwi gives us some other flexibility around Butterfest and makes it possible for us to leverage techniques that you would have only gotten with LVM as a foundation. But LVM is terrible on in the context of the public cloud. Not because it's not a sound technology, but because the drives themselves are already striped. So anything that you're actually using in an NVMe drive, you're not using one, you're using multiples underneath, and the LVM structure doesn't add any ability, like the increase and decrease of the volume size is already there, right? You just have to increase and decrease the file system size. And if you need another partition, that partition can take advantage of another EBS volume, and then you don't decrease the I/O performance that you have on the volumes that where you need it. So if you're doing something like a var log or /var, and you're creating a database, and that database is living inside of that EBS volume, you don't have to sacrifice your operating system performance to in fact use that. One of the things that we can take advantage of with Butterfs is we can use the snapshot send and receive the contents of the current var to the new EBS volume with whatever IOPS reservations you have in total, and then that can then go back into place on the instance, right? So now I can mount this new EBS volume with all of the content that I had in the original /var, and that just is a snapshot. So there's not a waiting period. There's just make the send, quiesce the database, push the mount, and then you're done. So minimal downtime. We can take advantage of a lot of that flexibility inside of the operating system. We can shrink the operating system, which is one of the other things that we really like, and is a big deal, right? Because a lot of people, I do this. I'm totally guilty of this. I will stand up an instance, build CentOS or Fedora images for the marketplace, and then I will shrink the volume. and that means that I can have a 60 gig volume for a few minutes while I create my artifacts, and then I can decrease it down to 20, make a snapshot. That AMI is exactly what I need or it has all of the content that I need to just make an improvement to the base disk, and then shoot that back up to the marketplace.
A question about, you mentioned Amazon Linux. That is also a kind of Fedora based.
It is now, yeah. So,
what will the relation be here?
Oh, okay. So,
I'm a bit confused here.
Well, we work. So I work with the Amazon Linux team as well. So when we first, long time ago, this was the idea of Amazon Linux. What at that point was 2022, and then it became it slipped. Was envisioned by Max Spivak, a former Fedora project lead, and Max wrote the documents, created the vision, for what this would look like and how we would do the implementation, and then he got another really great opportunity. He's working at Google now, and so one of the things but he left us that legacy, right, of how Amazon Linux could be associated with the upstream experience in Fedora. And originally the goal was to branch at F35 and to use F35 as a foundation for the first version of Amazon Linux 2022. And the concepts there are twofold. So are you familiar with Amazon Linux? And so this is a great, yeah, this is a story that'll make Peter's hair curl a little bit. This is, Amazon Linux was originally created because they wanted to the senior leadership wanted to accelerate their support for new hardware. And originally they built on RHEL 5, right? So if you're familiar with that, Rel 4 and Rel 5 were the original foundation for that whole cloud. You can thank Matt Wilson and Christian Gafton and a bunch of other guys like that. But the vision they had was to move a lot faster. And so the options for that were to build their own distribution or to do something that was a little bit derivative. Well, they started to take a lot of what was being done in the CentOS team and kind of move that into the Amazon, into what they called Amazon Linux. So removing trademarks, doing all the things, focusing on the hardware that they had at hand and the modifications that they did to their hardware. There's lots of things, there's security chips and all sorts of things to keep you from landing in the actual flash RAM, things like that. And so they wanted to make sure that they had those improvements in place pretty much immediately. And then they thought, you know what, we can make this available for customers, and customers can use it too, and we'll find out more about it, we'll get more bugs. And we all know this story, right? We've all used CentOS. So the goal there was to keep that consistent for customers. And so 1 year turned into 2, turned into 3, turned into 4, all right? And then there was a PHP version, so there's PHP 4, then there's PHP 5, there's PHP 6, and there's all these customers who are using it, and there's all these people who, we had the business discussion right earlier. Here's the data-driven part of the complexity of the data-driven part is like, well, we have all these customers who are running PHP, but we need the but they're running PHP 4, but these customers need to have PHP 5. And so then you started to see this like hodgepodge of things that were there. Something that very similarly was happening inside of the Red Hat community. And so, that's the birth of modularity right there is finding that experience. Well, we all had the same experience around trying to maintain multiple versions and software collections and all of that. And so Amazon Linux 2 became this really complicated, hard to maintain, way far away from, way divergent from where it was originally, and so, like compatibility was not an option, and people, but we still maintained kind of the same structure as the CentOS builds, and it made it easy to use a lot of the originally the Rel 5 stuff, and then the Rel 6 stuff, and then Rel 7, and then some of the 7 and 8, right around different kernel versions. And then, so Amazon Linux became Amazon Linux 2, and Amazon Linux 2 kind of tried to push the GCC much farther. And then Amazon Linux 2022 was coming up, and then that structure, they restructured, we reorged, COVID hit, things happened that impacted lots of people's expectations. And that slipped into Amazon Linux 2023. Amazon Linux 2023 ended up I wouldn't call it forking, but branching from F36. And there was never any goal. This is one of the things that Max set up. Max never had a goal of being 100% AVI compatible with Red Hat. His goal was to be 100% focused on customer problems and customer experience, and to go through that in the context of what was inside of the distribution. That said, that they don't have, they have very specific goals around support, right? They want to support the machines that they have in their data centers. They want to support the configurations that are important to the services that are running. So that makes it much different than what our goals are in Fedora. My goal in Fedora is to ensure that if there is a workflow that we can help a user integrate, then we want to make sure that we're helping them to integrate that in the context of the Fedora experience, right? And leading them into the workflows that we are perfecting, right? So, like where we might have very specific goals around ensuring that we have like a baseline support for ButterFS and for other component parts, The Amazon Linux team will be focused on what their performance requirements are for EBS volumes, what their what the Lambda service needs in order to have a good foundation for container-based workflow, and they don't care if the package if there's an extra Linux, an EPEL package that's associated with it. That's not important. That's more like that's you can go and bring that, compile it, let us know if there's a problem, right? And they do a public PFR, just like we do, and they work off of that based on a data-driven approach, right? They prioritize based on customer demand. We prioritize based on where our expertise is and who's working on the project at this point. Like who's dedicated? Yeah. So is that and I think that, if you look at the work that that Microsoft did with Flatpak or Google's done around Debian, you would find that you have the same kind of experiences. And we've made some really interesting. We've had lots of really interesting conversations, and I can talk about a lot of the ones around Amazon just because I'm so deeply involved in them. Like when we were talking to the SDK team and helping them to understand what our problems were and how we could help each other. One of the great, this is another one of these great moments, like getting having someone make their first commit, is we were working with Kyle Knapp, who is responsible for most of the work that's done on the AWS CLI development, and Tomaszek asked if he could be a part of that conversation, and when he started down that road, we started having a very serious discussion around Packet. And the Packet implementation inside of AWS CLI 2 is the first one. It's the gold standard that I'm leveraging to talk to other teams about how they can integrate back into that, and not just Amazon. At Google, talking to Zach and his team at Google, and talking to David Duffy and his team at Microsoft to make sure that they understand that we have this consistency model inside of the Fedora experience that will give us what we need. In terms of flexibility and rapid innovation. Because AWS CLI team, literally, they release every day. If you were paying attention, Bodo 3 is out, and then out, and then out, and then out. It is painful if you don't have a good automated process for dealing with it. And Nicola Copa on Tomasz's team is co-maintainer, really primary maintainer as far as I'm concerned, with me on that project.
Efficient time now.
Okay, great. I'm out of voice too, so it's a good time for me to take a rest. Awesome. Any other questions? Internationalization, specific technology support, something you're working on, you think you would like to bend the rules on, that we can maybe help you?
Vim versus Emacs?
I'm an Emacs man, so my life is all about eLisp. But Nano works, Vim works. They're all just an install away. We have, that's another thing, is that the infrastructure team creates packaging for the updates and the repos in each one of our individual standard regions. So, whenever you're pulling your updates for Fedora, you're in fact not creating egress charges in the availability zones. You're still pulling from the same locations that you're in fact you're working in. We use CloudFront as a foundation for that. Okay. Thank you.
Hey, that's your computer, not mine. You could do whatever you want to your computer.
It's not mine. It's not my computer. It's somebody else's computer.
Sure. So hello all. Yeah, well. So hello everyone. My name is Neil Gompa and this is David Duncan, and we're here to talk to you about Fedora Cloud KDE. This is a bit about all the stuff we kind of do and things. The most important thing is I do a lot in Fedora. I do a lot in KDE. I do a lot in CentOS and other places. David here does a lot in Fedora, and he does stuff for the cloud. And we're here to try to show you what we're trying to do together.
I buddy up with Neil a lot, honestly, but that's because he's a great mentor and super helper. So I've learned a whole lot in the context of the things, partly some of the things that we're going to talk about today, and then also just generally about Fedora, and you know, it's been a great experience for us to just work together on many things.
Exactly. Yeah, so we first want to talk a little bit about desktops in the cloud. The thing about, you know, virtual desktop infrastructure is it's been kind of a holy grail of sorts for, gosh, I don't know, like decades at this point. People have been wanting to eliminate hardware at the edge for as long as it's been possible to have computers connected to each other network, because in the very beginning you didn't have hardware at the edge. You had these thin terminals, dumb clients, whatever you want to call them, and then they would go and speak to like some kind of mainframe or supercomputer or whatever. And in the current era, now computers do stuff, but the problem of people breaking stuff is also still true, and so they'd like to have a way to do desktop computers without the computer part at the desktop.
So, and part of the reason this came up as something that we thought was super interesting to do is because...
You might want to talk closer to the microphone.
Oh, yeah, sorry. So one of the things that we thought this was super interesting to do is I was having a conversation, just sort of a casual conversation around use of desktops and in graphics intensive workloads, right, like film and animation. And I was having a conversation with someone around, like an architect around this, who's responsible for a fairly major customer, Red Hat customer, and it was pretty animated, right? And I got somebody from our media and entertainment group at Amazon to talk to them, and I just listened, right? And I thought, you know, there's a bunch of free stuff out there that we could use to do exactly what's going on in these, you know, in this multi-million-dollar solution. And the first opportunity I had to talk about it was to talk about it in the context of the RHEL workstation. And so RHEL workstation became one of those things that I was like, we've got to beat down the doors and have this available for anybody who's, you know, who's doing graphics intensive workloads and wants to see how this works. And
it's a thing now.
It is a thing now. Yeah, it's very exciting to me is that we have, and you know, obviously crafting something like that was really interesting because we had to craft it in a way that didn't create a cannibalized workload for server. Just generally in the cloud, right? If you run anything anywhere, you just run the cheapest one, right? So we wanted to make sure that people were using this for a specific type of workload, which was single purpose, right? You want to have 1 or 2 users for a RHEL workstation. You want them to have task-specific workloads that are user-centric, and other than that, you know, the functionality of the bits is kind of the same. And so we wanted to make sure that we had, you know, the right kind of business objectives around that. And it led to creating this like big screen around what our market model would be, and how we would price that, and again with all of this, there are.
Where's the open source product?
Yeah, where's the open source product to go with it, and where, you know, how do you create an upstream for that kind of an experience, and Neil and I thought about it, and we thought, you know, this is the way we can actually make this happen.
Yeah, and then from a community perspective, there were a number of people who had approached me over the years asking about being able to do some of these kinds of things for much more prosaic use cases, you know, thinking about things like, well, in libraries, they want to have thin client terminals because the computers need to be cheap because the kids are going to break them. And they'd like to not have to spend thousands of dollars to replace the broken computers. And in schools where they want to do something a little bit more powerful, but they don't want to really expose them to the hardware because, you know, in labs and whatever, they're usually using Chromebooks. And Chromebooks are not powerful enough to do certain types of things, but, you know, you still want to teach them in real environments. And then we kind of get to environments that are a little bit more interesting and special, and that's developing in the cloud for the cloud, right? So a lot, in the past 10 years, we've started to see a larger shift towards developer experiences tending away from Windows and macOS, surprisingly, towards Linux. As of last year, the Stack Overflow survey shows macOS and Linux basically neck and neck, with them trading blows like year over year. And I think this year, Linux actually surpassed macOS in terms of developer preference. And one of the bigger challenges that's around doing a lot of the developer type stuff for cloud applications is that the best developer experience always requires a whole bunch of like tools that you run locally in your environment integrated with your IDE and things like that. Even the best web IDs, and there's a lot of good ones, like especially like, you know, Dev Workspaces and OpenShift and stuff like that, and Cloud9 and AWS, right? They provide a lot of capabilities and interesting possibility, but nobody's building, like in the community space, nobody's really building tools for that. They're building them for your computer because that's the stuff they're interacting with. And we got to bring that kind of experience into the cloud as well, especially if you're maybe in an emergency situation or far away, or God forbid you have to work from your phone.
Or an intern.
Or an intern. Or an intern. Or a contractor. There's a litany of reasons why you'd want to be able to do this, and we wanted to be able to do this with Linux because there isn't anybody really doing it with Linux. And it seems like a big opportunity, which kind of leads into why are we doing Fedora KDE for the cloud? Well, because Fedora KDE SIG, which is, you know, the SIG I chair, we maintain the KDE stack, and we have a great relationship with the upstream KDE community to be able to provide an excellent experience with that stuff. And as part of being able to provide that excellent experience, we provide the fresh KDE software as upstream's releasing it, and we collaborate with them to enable features and capabilities that we feel our users for our various targeted audiences would actually benefit from. And that kind of leads to, you know, you want to talk about kind of artifact stuff?
Yeah. So our excitement today was that we wanted to demo this, but there was a rollback that eliminated the Wayland support, and so we are left without Wayland support and with a requirement for XOR utils,
which also doesn't
exist in Fedora. And but what we did do was to create a series of playbooks and configuration that would provide a lockdown desktop for support, right? So now you can actually create the KDE configuration on top of a Fedora cloud-based image. That Fedora cloud-based image then can be used with a security group. There's a security group that's created, and that security group locks you to wherever it is that you started that instance from. So like I started one today and created it in my account, and I have a single IP address that is associated with the hotel that's, or whatever the hotel network looks like for real, I don't know. And that, you know, prevents you from having something that's just wide open to the rest of the world. That locks us down to a specific client. Now, the client that we use is one that, so it's what I know, right? So NiceDCV is the client, and that's what we were excited about using. NiceDCV happens to be free for use on top of AWS, and the reason we wanted that experience was because it is free, right? And the excitement for us was that works in the context of the GPU-based instances, which we can support on Fedora. And it also works on just general hardware. So if you have something that's like a smaller workload, or you want to do an experiment and roll something, maybe you want to roll something in KDE. I don't know.
Yeah. Like you could also just, one of those things is like maybe you're prototyping a new lab environment for some kids in a school that you want to have an instance up to like see how that's going to work and make sure everything's good. You could do it in a small Gen Pop instance, make sure everything's going to be great, then save it, and then when you're rolling it out for real, you can roll it out in the right kind of configuration that would be needed to support it for the kids.
Right. Exactly. And I mean, I know we're all constrained to like lots of security requirements, and anybody who's in the in a security team of sorts here, you have my condolences. I know how hard your campaign requirements are, and everybody wants you to produce results, even when there's not a security bug.
Especially when there's not a security.
Especially when there's not one. So I run into this a lot in my in dollar day job, where I have an instance that's running, it's not optimized. Everybody knows it's not optimized, and they know that I'm running it at whatever 3% of its actual optimized use model, and so just very quickly creating a machine image from that, and then snapping it, making it possible for me to just start it over again from an S3 snapshot makes it a lot cheaper and decreases the security profile to something that people can live with.
Hopefully.
Yeah, hopefully. So those are if I encrypt the snapshot. Yeah.
Right, exactly.
So the goal here was to create something that was super simple, and that we could just get to the next step. So we're doing the install of a nice DCV, but we'll have to rev that once we get the code for the Wayland support.
Right. And the idea here is to demonstrate, this was intended to be a prototype to show you can take the Fedora cloud base, you can stack on a desktop, do some minor configuration tweaks, and suddenly you have a cloud desktop.
Which we
almost were there.
Yeah, and then, well, Neil's working on something else, though.
Right, and so that's part of the future features part of this. So some of the things I've been having a conversation in the background with the KDE folks upstream is the idea around headless KDE Plasma. Now, if you may have not seen my talk at Academy, so I'll kind of quickly recap something that I talked about there when I was talking about Fedora KDE, is that for KDE 6 in Fedora, we're only shipping a Wayland environment. No X11 session, all that stuff's gone. X11 applications will of course work in the Plasma Wayland session, but we're not doing X11 for KDE Plasma 6.0. Upstream KDE will have the ability to be built to support an X11 session, but we're not shipping that in Fedora. On top of that, there's been some efforts upstream in KDE to develop a way for Quinn, the compositor, KWin, to have a headless mode that can then be backed by RDP to use as the ultimate head for running the Plasma desktop. So then we can use RDP and have a fully free stack for being able to do a virtual desktop from the cloud to anywhere. And this will give us all kinds of other capabilities, but the most important part, because it's fully open and generic, we can have this in any and every cloud, rather than being specific in this case with the prototype with AWS's nice DCV.
I mean, you can use it anywhere, but the thing is that it's free when you use it on the platform.
Yeah. But more importantly, because it's all open source, you can kind of see how everything works, you can figure it out, you can improve it, you can learn from it, and you can build on top of it. And that's the key aspect that we want to do with the Fedora Cloud KDE. And we're kind of targeting this to be something that we can start really building out when we land Plasma 6 within Fedora and start working on that headless Plasma mode.
Yeah, and this is like something that kind of dovetails with some of the other things that I think are really amazing, like the Linux system roles, making it possible for you to just find a way to apply this in a way that is kind of generic.
Yeah, and so if you're interested in this kind of stuff, like in addition to the Fedora Cloud SIG and working group that's working on this, right? The Fedora KDE SIG is actively working with the Cloud working group on this front. You can see our lovely members that are in there and all the avenues in which you can come talk to us. We're on Matrix, we have a mailing list, we have an issue tracker. Come in and join in the fun if you're interested in this topic. So any questions?
Yeah, awesome.
And this is why we finish with 5 minutes to spare.
Thank you very much for the presentation. And I'm an avid KDE user in Fedora. But as an avid KDE user, my question really was from the start, why KDE in this case? I love KDE,
yeah.
but it's one of the most resource-heavy desktop environments out there, and in the cloud you pay for resources.
So,
if it's AWS, that means you pay more, while with this scenario, I would be really interesting deploying on a VPS. When you have like 4 gigabytes of RAM, what KDE can you think of? So my question is, how much of this work can be applied to a lightweight environment like IceWM, like what we used to use 10 years ago? And what's the rationale for using a heavyweight environment like KDE in the cloud?
So let me pick apart a couple of things here. So the first is the thought that KDE Plasma is the heaviest environment, or one of the heaviest. No, it actually isn't anymore, especially when you're running in the Wayland mode. The minimum KDE setup, which is just the desktop, shell, compositor, and you don't have the KDE PIM services, which you don't need in the cloud environment anyway. So
those out.
yeah, so if you take all those out, your KDE Plasma desktop runs with 120 megs of RAM. And that is basically comparable to LXQt, XFCE, Mate, with the added advantage of actually being fully actively maintained and having Wayland support and supporting all these kinds of new features, being able to be hardware accelerated optionally through things like the cloud-based GPUs and stuff like that.
Yeah.
The second aspect of this is most of the stuff that we're trying to do will probably not work on your average X11-based environment, because the idea is that we're trying to leverage modern protocols that are network efficient for being able to make it so that it's responsive over the internet. So like the usage of RDP as an efficient transport and communications mechanism for the desktop has basically not been successfully done in a reasonably performant fashion with anything backed by an X11 server. But with the Wayland server, we're able to cut out a lot of this fat and have a very optimized method of handling this at the compositor level, at the renderer level. And so that's why this is able to be done. And you'd be surprised that how much less resources you have when you also don't have to figure out hardware quirks.
Yeah. Okay, thanks. This is clear. Maybe there is a trade-off on the cloud resources, but versus network resources, which are actually often the ones that...
Yeah.
Well, yeah, and remember that one of the things that we're taking advantage of is one of the things that we're taking advantage of is that you're not going to use this all day, right? You're going to use it for task-specific workloads, and then you're going to put it away and go do something on another system. So you can stop it all day. That means you're paying for the storage, the monthly, like you're, in this context, you're paying for monthly storage for the volume, but then the compute power, which is your actual, your heaviest cost, you're using it opportunistically, right?
Okay, thanks. So, and could you also elaborate on what this could be used on EDS?
There is nothing that would stop once we have the final version, which is generic, that would stop it from being used in a traditional, in a virtual provider cloud system like, say, Linode or similar.
Yeah.
Those are totally possible to do. Like, the main constraint is making sure that your I/O and network performance are high enough in the environment that you're running in that this doesn't like choke.
Yeah, and I think the thing that, you know, in the context of what we've done here, we have one deployment script for the instance that's created, right? And you can make some modifications in your extra arguments, right? But you don't. But effectively, there's just a super simple way to do it. We can make many, right? So then the question becomes, how do we do that? You know, what's our easiest path forward to doing the provisioning? And the provisioning itself is the one thing that we would focus on. Yeah.
Okay, I have a question about the keyboard, and I always have a problem with things like key shortcuts. You know, Control Alt F1 and or F2 whatever, and your session is gone. And how does it look here?
So, I mean, I can give you that answer.
You want to give it? Yeah, go for it.
So there's going to be two parts. One is going to be based on the client, and the client itself will allow you to grab the whole keyboard, right? So the client that we're using in this context gives you that whole keyboard. the RDP, the KRDP will also give you
Right.
access to the whole
So
keyboard.
if you're using the KRDC client, that is the client side of RDP from KDE, there's an option in it to make it so that it grabs the whole keyboard and intercepts all actions before passing it on to the host. And so you can use control, special characters, all the fun stuff, or Alt-GR and doing third, fourth, fifth level modifiers, whatever crazy thing you need to do. It'll pass it forward to the remote session.
Yeah, you were in my previous talk where I talked about my love of Emacs, but I am a keyboard maker.
He really is.
Yeah.
Okay, and why did you use Ansible instead of Terraform? I know that because Terraform is like, the basic, like the most basic tool, and changing from one provider to another is quite simple.
Well, I think it's super simple, right? But Ansible, just like falls into the family, right? So I feel like
there's also the other part of it of like the only thing Terraform would actually do is make the cloud-based instance.
Yeah, and
You
then-
still need to do everything else somewhere else, and that would be done in Ansible. So if you're only doing one step in Terraform and all the other steps in Ansible, and the one step is trivial, you might as well do the one step in Ansible too.
Yeah. And then on top of that, one of the things that I mentioned was the concept of the Linux system role. So the concept around the Linux system role has been something that's entertained me for a long time, and thinking about how we can have those in the context of Fedora Cloud is something that I think is beneficial. Right.
I have two questions. I was really looking forward for the demo, so I'm pretty sad. That
Me
that
too.
is-
So are we.
So can you later post something on the Mastodon? I would love to watch that because honestly, I will probably not run the playbook. I will have no time for that.
I understand. So yeah, I mean, I think so the answer to that is, I talked to Paolo, I talked to the GM for the product and was like, hey, we don't see the Wayland support. And he was like, oh, I'll have to get you the review code. And so as soon as we can post it out, we'll just make a movie on the GitHub repository, on the README.
And the second question, so what's the feature where I can expect something super easy like Linux media writer or something which I just click and got it in the cloud, or AMI, which I spin up in.
So the goal is that once we have the generic version, we actually are going to produce a layered image product, or variant, or whatever you want to call it. Layered product, layered spin on top of the Fedora Cloud-based edition.
Yeah.
That we can ship and give AMI launch buttons and give them steps to like how do you connect to it automatically and all that other fun stuff.
Yeah.
So when approximately?
I would be very hesitant to give dates because I don't actually know when Plasma 6 is going to release.
My guess is let's wait until Paolo tells me that the Wayland code is ready for the client.
Yes.
And then if the KRDP is ready, then that's the one we'll choose because we want one that's just functional everywhere.
Right, and like the KDE community has been estimating like we're looking at seeing first Plasma 6 released by the end of the year, early next year. So if everything optimistically works out, I'd like to have a preview build that we start making available in Fedora as a generic image in the summer, maybe, or maybe in the fall, and kind of go from there.
I noticed you didn't specify which summer.
Summer of next year, Adam Williamson.
We don't make forward-looking statements, I'm sorry.
Yeah, quick question. So KRDP is an RDP server, right?
That's correct.
Yeah, KRDP is a new library that the one of the KDE folks has been making to encapsulate all the functions of creating an RDP server to plug in as part of a backend for Plasma Desktop.
It's not as lightweight as so it's a protocol that we can adhere to and make.
Yeah, but here's the question. Is there an architecture diagram how it plugs into SSSD for authentication, for example?
That'd be kind of awesome.
I think we're going to have a conversation with AB about that.
Yeah.
No, there's some other stuff that we have to figure out, like having the ability to render through RDP is only the first step. We have to also figure out authentication, all this other stuff. And that's why I'm saying, like, I'm crossing my fingers for being able to do a preview next summer, but I genuinely don't know, like, what it's going to take to get us to a point where this is something that I'd be comfortable with, say, this is a generally useful thing that you can kind of, sort of, maybe rely on building your own versions of to then roll out for your own thingies, and then somebody might want to do something more interesting with it down the road.
No, yeah, that's true. And then,
Wait, but at the moment, so you spawn a VM, it runs key RDP, but how the actual authentication of the user session happens?
Well, right now we would be auto login.
Yeah.
So we don't have a better way of dealing with this right now.
So there is simply no way to protect the VM from unauthorized connections.
Okay, so the nice DCV actually contains a client. We can create base logins on the box.
And RDP itself also supports handling user password logins as well as Kerberos logins, but we have to hook all that stuff up.
Yeah. The plumbing for that would be like second generation.
Yeah.
Yeah.
None of this stuff is simple.
Yeah. But I like where you're going. There are other things that are awesome about that, like the SSSD implementation with like Instance Connect models from different public clouds would be really cool. And
that would actually be super nice because then we can plug it in through PAM back into SDDM and then verify and authenticate the login session automatically through your local credentials.
I think I've got like a 700-day-old Bugzilla with Amy Farley about some of the things that we could do there. Actually, Amy's probably moved on.
Yeah, I don't know who would be doing it now.
But
iPads will be way more useful now.
Yeah.
Yeah. Cool.
All right.
People came. Okay. Actually, I hope we have enough seats. Okay, so I'll just go ahead and get started. Oh, okay. Oh, is the camera not? We good, we good? Are we streaming? Oh, God. Okay. All right. There's seats up here if you need a seat. There's 2 seats left. So here today, I'm going to talk to you guys about Podman Desktop. Now, I made this proposal, and the CFP review committee was like, hey, Mo, this sounds great. What does this have to do with Fedora? So I'm going to tell you what this has to do with Fedora. I've never given this talk before, and it includes a demo that may not work because I'm having computer issues. So I just wanted to caveat with that, too. So I'm Mo Duffy. I'm a UX designer at Red Hat. I also work on the Fedora design team, and I work on the community design team. Yeah, so this is sort of my manifesto for Fedora. If you were in Matthew's session this morning, I had asked him about strategy and stuff, and this is sort of what I was getting at. So like in Fedora, and can I walk to the screen? Am I on camera if I do that? So this, we tend to sit in this spot, desktop user, right? Like it's our bread and butter, it's our largest user base, uses Workstation or one of the desktop spins. But you can do so much more with Fedora as a technology. So this is, I have a blog post if you want to read it at some point, the QR code is there. But this is what I call the Fedora F model. And the idea is, yeah, plenty of people can just sit here, use Fedora as a desktop, be perfectly happy. They don't have to do anything else. But if you want to explore, the latest and some of the OS bits that we're building and what you can do with it, you sort of proceed up the F. Maybe that's not a good thing to say. But we will proceed down the middle fork. The orange thing. That is where this talk is going to talk about. The pink and purple one at the top is more oriented towards Internet of Things. We have Fedora IoT and Edge stuff. I'm not going to talk about that, but that definitely comes into play. I'm going to show you Podman Desktop, and that actually has a microshift plugin, so you can deploy images to a microshift and play with that. So I mean, we could fill in that a little bit more, but we're just going to focus on this orange line. And basically the use case is developers who are using containers to write and then deploy their apps. So this is how it sort of all relates to Fedora. Does this make sense? Like, and when I was talking to Matthew, I was like saying, we should focus towards some of these kinds of use cases too, because then when we were doing the Fedora website redesign, and I was talking to different Fedora users, a lot of them were like, I use Fedora Workstation and it's great, but like, what is Fedora Core OS? I don't get it. And it's hard to explain, but if we sort of talk about Fedora and model it for people more as being this broader F than just this down here, I think we can kind of teach people and educate them and get them excited about it and understand what it is. Because I think we all understand quite well. It's onboarding people that is where we have the problem. Anyway, so I put in the talk description that this is beginner, so I see a bunch of you in here that I think are going to be quite bored by this. But this is how I sort of explain to people what are containers. So you sort of move from bare metal, like a computer is a computer. Like this is a computer, it's a physical thing. And you run software on it, the app's at the top. So then you get into virtualization, right? So you have the operating system on your actual physical computer, and then you have a hypervisor. On top of the hypervisor, it's basically, let's make many fake computers and run them on one real computer. So that's virtualization. So containerization is, let's create fake operating system installs that it's not even the full operating system, it's just components, and I'm going to lock it off using C groups and make it so one computer seems like many, but it's not, and it's totally fake. So the one way to call this is like abstracting into the space almost. And another way is it's just making lots of fake stuff and just layering and layering and layering. So this is how I like to explain containers. So Podman is we ship Podman in Fedora. It is the main way that you work with containers in Fedora. Podman itself, if you're running it on a Windows or a Mac, and see here we have the host operating system, Apple emoji or Windows emoji. It's based on virtualization because I think Apple and Windows, they don't support either Podman or just containers in general. Containers are Linux, right? So they need virtualization to be able to run Linux, to be able to run these container engines. So the VM that provides Podman on Macs, it's CoreOS. On Windows, it's Fedora right now, and that's because of a WSL issue. But when we come out with Hyper-V support, that will likely use Fedora CoreOS. But when somebody talks about using Podman, and they talk about using Podman on Windows or Mac, they're a Fedora user. So just remember that. It's like, again, what does this talk have to do with Fedora? Well, let's onboard Fedora users that use Mac and Windows. Why not, right? You don't have to use Workstation to be a Fedora user. You don't have to use Linux on the desktop to be able to use Linux. So we should embrace these users and help them and bring them into our community. Anyway, so at the top here where I have the purple delineation, and this shows, you know, Podman is native to Linux. Containers are native to Linux. It's a simpler model. But where you have the purple there, that's basically what Podman is. So the apps on the top are your individual containers, and Podman supports everything you need to run them. So, oh, and I do have a little cultural note. The 3 seals in Podman are Stelkies. That is an Irish myth about seals that turn into women. Their names are Caitlin, Margaret, and Rose. So, very good. Cultural relevancy. Okay. So now we'll talk a little bit more about Podman Machine here. But actually, I already said all that, so I'm just going to skip this slide. I've not given this presentation before, so I'm not super smooth here. Okay, so now Podman Desktop. Podman Desktop is a developer-oriented user interface that makes all this stuff approachable. Podman, for many years, there was no GUI to work with it, so you had to work with the command line, and that's fine. That's great. You can script things. You can play around with things. Someone like me, I'm more visual. I'm less deep into the lower-level tech. I still want to play with containers and build apps and deploy them, but I maybe don't want to be sitting in a command line all the time. So Podman Desktop makes it very approachable. Podman Desktop also, just like Podman, runs on Linux, Windows, and Mac. So we also can get Fedora users basically via Podman Desktop. So again, just relating it to Fedora there. Can you tell I was a little spicy about being told? What does that have to do with Fedora? The other relationship here with Fedora and Podman Desktop and Podman is Podman is run in our OpenQA for Fedora. And even though I don't think it's in one of the core packages, but it's still considered a package that will, you know, stop a release if it's broken. It's really important that we have a functioning Podman when we do a release because so many things depend on Fedora CoreOS having functioning Podman. So we're actually looking right now, and I've been talking with Adam Williamson about adding some tests to the Podman tests in OpenQA to make sure that Podman Desktop works, because when Podman Desktop has a problem, it might have a problem that finds a bug that just the standard testing that they do right now wouldn't catch. So, okay, so now the next level of abstraction. So these are the layers of abstraction that we talked about before. So the next level, and yes, I will caveat, I'm not an expert, I'm still learning, especially the Kubernetes stuff. So Kubernetes is, let's make a fake supercomputer. I don't know how accurate that is, but that's how I think about it. And basically, you're just taking each one of those blocks where you have the host operating system, the container runtime, the containers, and you're just multiplying them, and you're calling each one a node. So you can scale an app up or down based on demand. You get all sorts of different services from Kubernetes. You can cluster together different things, but it's basically building a fake supercomputer of all fake computers that somewhere sit on hardware. You don't know where the hardware is. You don't think about the hardware. So again, it's just another, you just think about going up a layer cake, right? It's sort of the thing on the top. Okay. So what does this Kubernetes thing have to do with Podman Desktop and Podman? The idea is you start with a container, you're building an app, you're running Podman Desktop locally, you're playing around. You might not even be building an app. My main use case for using Podman on Podman Desktop is running PenPot, which is a UI design tool. And I like running it locally because I have all the files locally. I'm not relying on a hosting provider or anything. I own my materials. I really like that. So I like to run it locally using Podman. And it's not, I didn't write the app, I'm just running it. There's two ways when you start getting more complex apps, you might have multiple containers in an app. You might have a container for the front end, a container for the back end, a container for the database. Docker has something called Docker Compose that lets you group containers together into larger applications, but it's not really compatible with Kubernetes. There's also, what Podman does is it has the concept of it creates a pod using a format that is compatible with Kubernetes. So if you do things like, there's two options here. There's the blue box at the top and the purple box at the bottom. If you go the purple way, it's sort of easier to get to Kubernetes because it's already formatted that way. If you are working with an app that uses a Docker Compose, and PenPot would be an example, they ship with a Docker Compose file. Podman and Podman Desktop can convert it to a Kubernetes format, which you then can deploy to Kubernetes. And once you go into Kubernetes, you have different levels of things you can do. OpenShift Local, Minikube, K3s Kind. These are examples of really scaled down versions of Kubernetes that don't have most of the services you would have in a full-blown cluster, but they let you have a local Kubernetes environment that you can play around with to see how your application would work in that sort of environment. And then you have things like OpenShift, and of course I have OpenShift on here, we're for Red Hat, I mean, come on. But you can do things like managed services, you can push out to Red Hat OpenShift and be like, hey Red Hat, I'm just working on this app, I don't want to do the sysadmin thing, I don't want to do cluster admin, you keep it running and I'll pay you. So you can have that option, just pay somebody to do that stuff and I'm just focusing on the app. So once you build containers in a way that you can deploy it out, you get the benefits of being able to scale. You get the benefits of, I have this awesome app, I want to focus on the app, the whole scaling and multiple locations, like I don't want to work on the complex stuff. I just want that provided to me as a service. If you run it on Kubernetes, you get that kind of stuff. And a lot of hosting providers are Kubernetes providers. So it's something that there's a rich marketplace that you can go and find a provider to do that. So that's sort of the whole ecosystem. And Podman Desktop has plugins that will let you push to Kubernetes. And that is the thing I'm going to attempt to demo, but to a local kind. So let me get to, okay. So, and it's funny, Podman, and I think other container engines too, has this thing where it comes up with a name. And I've been having trouble with my machine because of assorted issues. It came up with the name Hopeful Panini. And it actually ended up working when it came up with that name, so I don't know what's up with that. But here, well, when you start Podman Desktop, you kind of get, I have the OpenShift local plugin loaded, so it talks about that. It says the Podman that I have. This is the dashboard. So I actually have a lot of things running on here. I can show you real quick. Where is it? I can go in. So this is a compose, so it's like a bunch of different containers that were generated by a compose. It's not podified because I tried to podify it and there was some network issue and I just didn't want to play with it. But I can open up the front end container and then this is, you can see localhost. I'm not cheating, right? This is actually running on the system using Podman Desktop. And I can go in, like I have the Fedora character library in here. And I can just sit here and work on PenPot, and it's all on my local machine. I do this a lot on trips like this because I can work on stuff when I'm on the plane. It's awesome. And then once I'm off the plane, I can upload it somewhere. It's very nice. But anyway, so I have that. But let's get back to our hopeful guy. So Hopeful Panini, I'm going to hit play, and that's going to start the container. It's just it worked. It's a very simple web thing. It works. Yay. Okay. Now, this is just a container. It's not a pod or anything like that. It's just a plain container. So what I'm going to do is I'm going to select it, and we have a feature called Podify, and it takes the container and it generates cube YAML for it, and it makes a pod. So I'm going to hit here. It's going to create a pod with this. I'll call it Hopeful Panini Pod. It's a nice alliteration. All right, now I have Hopeful Panini Pod, And you can see here, oh, sorry, I didn't delete my other demo stuff. That's all right. So you have Hopeful Panini Pod, and you can see it's running on Podman. If I go on this list and I do Hopeful, you'll see what it did is it took the original container and it stopped it, and it made a copy of it, and it put it inside a pod, and it called it Hopeful Panini Podified. So now if I go to it and I open browser, yay, it works, woohoo. Okay, so now the last trick I'm gonna do, hopefully it'll work, is I am actually going to deploy it to Kubernetes. So let me just show you what I mean by Kubernetes here. So there's something called kind. It stands for KIND, kind, or Kubernetes in Docker, but you know, it's running on Podman right now. And it's basically a very small version of Kubernetes that is running locally on my machine, and you can see where it's running here. So I'm going to deploy to that. So I'm going to take, again, I'm going to type hopeful, and I'm very hopeful this will work. So I'm going to call it, Hopeful Panini Pod to kind. And it's on the kind cluster. It's going to. All right, I'm going to hit deploy. Is it working? Yep. Oh, it's already running. Whee! Okay. So then I'm going to go to my list of pods, and you can see, where did it go? Is it this one? I think it's one of these, but I don't remember what I named it. But anyway, so you can see that it's running with the tag, it's running in the kind cluster. And if I do, I think it's cube control get pods, you can see that it's running, so just to verify. So yeah, that is just one example of what you can do with Podman Desktop. I have a bunch of stuff in here. One of the things I wanted to demo that unfortunately I broke, my blog is on DreamHost, and I'm not happy with them right now, and it's a WordPress. So what I've been working on, and I'm hoping to do a tutorial on it soon, is I basically containerized WordPress, and I made it so it will generate a static site. So I'm going to run a WordPress container locally and use the nice WordPress UI to write my blog and upload the images and all that stuff, and then generate static HTML from it. And then I'm going to have like a git commit thing, where like a post commit hook where it pushes out to a GitHub, and do my blog that way as a static, because like number one, like WordPress gets hacked a lot. Number two, I'm not happy with DreamHost, and I don't like being stuck with them. It's a fun project, but I did something to it and it broke, and I can't remember how to fix it. But you can do little projects like that, and that's one of the things that I have in here. And you can grab images, like I can show pulling an image. Let's pull a really good one. I hear it's nice. You can just type Fedora, it'll look for it, it'll pull it down, it'll add it to your library. Yeah, I don't know. I guess what else? Does anybody have questions? Was anybody hoping to hear something today that I didn't cover? What do you think about my my big F? Somebody's got to have opinions on the F.
How do you pronounce key.io?
You just pronounced it.
Okay, because in this city, when you go down to the water, there are keys. So the boats come up. All right. So Hello. QUAY is key, as in KEY. And Paul Cormier will dispute that fact, but I will dispute it back.
There's no Q in Irish.
It's key. It's key. It's not quay.io. It's key. So tell all the red hatters it's key, not quay.
But how do you spell it as Gaeilge? Because there's no Q.
Oh, I don't know what it is in Oscuelga.
So see, it's not really a Q.
But it's a key.
Yeah.
Yeah. Tell Paul Cormier that. Paul and the founder of Quay.io keep saying it's Quay, and it's key. Just pointing it out there. I love the F as well.
Can we get another Fs for another parts of journey in Fedora, like server?
So where would you see server fitting in?
So server, cloud, and all the other things?
Right, where do you see them fitting in? What do you think?
Definitely not on this F, at least not in the middle, but on the upper one, as well as I guess we can start with the server instead of desktop and go the same way.
That makes sense, actually. Have a separate F for, but you gotta let it. You can't force the F. This was originally an upside down L, and then it became an F, and it was like, but you have to. You can't force it. It's just got anyway. Sorry.
Right, grow naturally.
Thank
no
you,
questions? Come on, somebody has opinions about this.
It's
are we apathetic
colorful.
about it, or are we agreeing with it?
I like it. Yeah, great. It's better than my text file of Podman commands that I have to kind of. I mean, I'm not a developer. I'm a technical writer, but my Podman, I have a text file with commands and little explanations. So I mean, it's certainly more helpful than that.
Yeah, I'm a visual thinker, so I just find it nice to have all my stuff there.
Yeah,
Because
no.
I'll do a little project, and then I'll like not have time, and then I'll come back to it, and having it right there, it's very nice.
Yeah, no, your demo was great. I'm certainly going to look it up now. It's like I said, it's an order of times better than my text file of copy-paste commands.
I should put this up. We have podman-desktop.io, and we also have podman.io. I do want to mention that Ashlyn Knox, who also was one of the lead developers on the new Fedora project.org, did the work for podman.io as well, and we followed a very similar process. And it's github.com/containers/podman-desktop. So if you want to join in, we're an open community. It's an open source project. We would love to have you. And if you have any feedback, we'd love to hear it. Any other questions? Ideas? Jokes? No?
All right. Oh, here we go.
Kristen?
This might be a little left field, but we'll see. So I don't use Kubernetes, but I do use a lot of Podman at home to self-host things. And obviously, I'm just doing that by logging into the machine and running Podman. The deployment that you showed there, I really like that idea of being able to just push things from my machine that I'm working on to the rest of the house, but it's not Kubernetes, right? What are the other sort of deployment options I might have?
So I can't speak to the support we have right now for this in Podman Desktop. However, there is a Podman remote that you could use. So for example, you could set up a home server. And this is what I was telling Matthew today after his thing, is like, we got to do this and we got to make this a thing. You can set up CoreOS on a system, and it has Podman on it. And you can do, from your local system, Podman remote and push the containers to that system. Now, I don't want to say that we can definitely support it in Podman Desktop yet. I think I saw somebody had a hack to do it, but it's not definitely something I want to try to get on the roadmap. But generally, just from the command line, you can do that.
Okay, thanks.
And I think it's a good middle ground, and if you're doing some kind of home network thing, you don't need to do Kubernetes unless you're really
the host I have in mind
hardcore.
is not getting rebuilt.
Yeah.
But yeah, there's definitely options. And
The other thing is, if you did something like, we have something called Developer Sandbox, Red Hat Developer Sandbox, and it's free. It doesn't cost anything. It's an online Kubernetes cluster. It's not like super powered or anything. I mean, it's a free account. But you can deploy stuff to that too, and Podman Desktop has a plugin for that. So, I could have demoed that today. I chose not to because, I don't know, I just wanted to do kind. But that is another option. Like, if you just wanted to play with Kubernetes, but you weren't really sure, it's something that you don't have to deploy your own thing, so.
Yeah, I wouldn't mind playing with Kubernetes a bit more, but in this case, my use case is, can I make it easy to manage the home stuff?
Yeah,
So
yeah.
that doesn't work there, but it's still useful information.
Yeah, no, that's a fantastic question. Thank you. We good? Time for one more?
Yeah, this is actually like more of a comment. And first of all, thank you. Great presentation, very informative. Just with the supercomputer thing, I don't mean to be like,
supercomputer is a term, I
yeah,
know, and it means things.
I don't know, it just got stuck in my head, like maybe distributed operating system.
Yes, you know what? That is much better. And if I give this talk again, I'm going to use that phrase, because that's really what it is.
Awesome.
I love it.
That was my
Okay, no, that's brilliant. All right, thanks, everybody. I want to take one more picture, too.
Today we'll be talking about Sway, Spin, Sericea, various things about the topic. So, first of all, who am I? I've been in the Linux space for quite some time. Been Fedora contributor since 2013, and then since 2016, Sway packager and, well, user as well. So let's start from the very basic. What's Sway? Why we're talking about this? It's a drop-in replacement of i3WM. Drop-in is the definition of the project. That does not mean that is actually a drop-in. Nowadays, it's way closer to that idea, at least, but it's not like perfectly a drop-in in some very edge cases. Why have it at all? Because it's for Wayland. So i3 did not want it to migrate from X11 to Wayland. I'm not entirely sure if they changed their mind in between, but back in 2016, they were like, nope, we are X11, we are targeting that platform, we have a lot of code specific for X11, therefore we don't care about this new thing that hopefully will change everything, but maybe it will not. It's based on WL roots, so effectively, the Sway developers wrote also a Wayland compositor. At the time, there was, don't remember the name of the genome one, but they did not want to use that one because they believed that it was bloated and not up to the level that they were expecting. So they wrote one from scratch with the idea of creating a very small implementation, which at the moment, I think it's around 60,000 lines, which is not that much to be a Wayland compositor, but to be fully compliant with all the extension that Wayland has and had at the time. The first commit was in August 2015, so we are at the 8-year mark from Sway now. And interestingly enough, we have it packaged since February 2016 in Fedora. And the first release they had upstream was in March 2016. So effectively, we can say that Fedora is probably the distribution that has been having Sway for the longest period of time. And I have to say that I have been using Sway for quite some time because I packaged it a couple of weeks after I moved to Sway. So it was not very stable. At the time, I used to also have i3 installed because, well, it tended to crash, version 0.0. But still, it grew very well, and over time, it became very, very stable. Now, the history between Fedora and Sway has, I would say, 3 big parts. The first one is what happened before Fedora 38, then 38, and then 39 in the future. So before 38, there were multiple people that had their own spins or remixes based on the specific versions. I had mine as well. I think I published officially, so I had it mine based on classic Fedora since 2016. Then in 2017, probably I moved it to rpminspect 3. I published it on a Git repo, but never commented too much about it because it was basically my version of Fedora. And then a couple of years ago, I published it also with a blog post and telling a little bit to many people what actually I was trying to do and that kind of things. And in the same way, other people had tried to solve the same issue. So in May 2022, we decided, and a bunch of people, to create an official spin for Fedora 37 for Sway. That was the initial idea, but it did not happen. It did not happen because we were not very clear with ourselves on what exactly we wanted to put in that spin. What way, if it should have been a very basic spin or a more complete spin, who was our target user and so on. So we used a little bit more time than the Fedora 37 release cycle allowed us to do, so we ended up with Fedora 38. So in Fedora 38, we proposed the Fedora Sway spin change. That's also a link. It does not feel like one, but you can then find the slides in SCAD. I'll upload them there, and you can click a lot of things in the slides. And this change was about 2 artifacts. The first one was the creation of the Fedora Sway spin. And to be specific, the biggest change between Fedora Workstation and the Sway spin is around the packages. So the packages we ended up with are obviously the Sway packages. So Sway, SwayBG, idle, and lock, which are the very basic Sway packages that you can have. Dunst for notification daemon, Foot for the terminal, and that was kind of a long discussion because we have a lot of different terminals, but, well, in the end, you only have to pick one. So, Slurping Grim to do screenshots. So the first one allows you to select an area on Wayland, and the second one to screenshot an area on Wayland. IMV for the viewing images, Kanshi for dynamic output configurator, MPV for media player, Tuner for file manager, and SDDM and SDDMX11 for the login manager. Now, we'll be talking a little bit more about the last one, but as you can see from the list, we opted for a fairly complete version of the distribution in the sense that we are providing the majority of tools that a person might be using. There is also Firefox. It's not in the list, but it's there as well. And all of them, or all of them except the last one, are Wayland specific. So for instance, Foot, it's a Wayland terminal emulator. IMV, same thing. So whatever we could choose between an X11 native program and a Wayland native program, we opted for the Wayland one. The other thing that we proposed in the same change was Fedora Sericea. Now, a couple of comments on this. First of all, the name. The pronunciation, I've seen that many people struggle with it, is either Sericea or Sericea based on the kind of Latin you want to use. Classic Latin would be Sericea. Ecclesiastic Latin would be Sericea. I use the latter because I'm Italian. In Italian schools, you study ecclesiastic Latin, not classic Latin, but either would be correct. The reason is that Fedora Sericea, or Sericea, comes from Terminalia Sericea, which is a plant. And plants' names are pronounced in Latin. So, why Terminalia Sericea? First of all, because Sericea started with S, in the same way that Sway does, and so it was like a nice thing. The second aspect is that Terminalia Sericea is a tree, OS3 is a tree, so we found that similarity as well. Also, it's the common name would be Silverleaf, which was also one of the options of what then became Silverblue. So it was also a nice reference there. And if you look at Terminalia Sericea, you will find a lot of similarities with the Sway logo. And, the first one is the Sway logo. And the second one is the Wikipedia image of a Terminalia Sericea, just mirrored because they photographed it on the other side. But as you can see, there are a lot of similarities. So we thought that that was a good thing, and therefore we opted for this name. Also, speaking about logos, we also got a logo, and this is thanks to Emma Kinney, which is part of the Fedora design team, and she was very patient with us with all of the changes that we asked her multiple times. And so we also have a logo that is also very similar to the previous 2 images that we have seen, but obviously in the Fedora way. Now, we also worked a little bit on website things in the Fedora 38 timeframe. So first of all, we managed to create the spin page. It's a little bit weird because until Fedora 38, effectively, until Fedora 37, all spins had a page on spins.fedoraproject.org. In Fedora 38, some spin moved, or the new spins started to have pages on the new website. So we went directly in that path, and then I think that now every spin will move there as well. So we try to already be on the new website just to avoid the double creation of pages. Then we also had the Fedora Sericea page on the website as well. I'm not sure how many derivatives or editions have the page or had the page at the time, but for the same reason as before, we tried to already adopt a new standard because it was obviously easier for us. And also we created some documentation around this. There are still a lot of things to document, mostly because Sericea and Sway specifically are Wayland only, which means that, for instance, if you have an NVIDIA card, things might be a little bit more complex. Now, hopefully in the next few releases, everything will become smoother and even NVIDIA drivers will work perfectly. I really hope that. But in the meantime, it's, can be a little bit rougher there. So for Fedora 39, we proposed one change and then we inherited one, which is always good. The change that we proposed got approved and implemented, and I think is real since 3-4 days ago, rawhide build. So it should work. I've not yet tried on my laptop because I did not want it to break 2 days before before Flock. But still, it's Sericea XORgless. The idea here is that looking at our tree of dependencies, we are still importing XORG, which is not very good for a Sway that, in theory, should be XORgless. And the reason for that is that we are using SDDM X11, or we used to, and by moving to SDDM Wayland Sway, we can actually drop completely the XORG dependency. So this is what we have done, and now we have the builds without XORG, which is always also better because there were a bunch of weird bugs in the login page due to some not perfect configuration of XORG, which we didn't really care about because all the rest worked without XORG. So we also fixed a little bit the user experience there as well. The other change that we got, but we did not develop, so it's always nice because you get it for free, is the OS3 native container change, which is, I think, driven by Colin Walter and other Fedoras people. So now you can actually download Fedora Sericea directly from a Docker repositories or image repository. Now, for Fedora 40, we start to have some ideas. Those are not like written in stone kind of ideas. It's more like, yeah, we have thought about those kind of things. I've discussed it with a couple of people, but nothing is written in stones there. And the first one is the unified core mode. So I think in Fedora 39, Silverblue and Kinoite are going to move to this unified core mode, which basically is the new suggested way to create RPM OS3 images. The classic way is now deprecated. We are still using the classic way, so it would make sense to actually move to the non-deprecated way sooner than later. And it should not be a huge change, mostly because due to the fact that in Fedora 39, Silverblue and Kinoite are already doing it. If they are going to be successful, and I really hope that they are, we will just have to copy whatever they have done in the previous release. So it should be something reasonably easy to do. And the other thing that we have been discussing, even though there is no clear consensus on anything exactly around this, is more Flatpaks. And this is more on the Sericea side than the Spin. And the reason is that, for instance, I'm not very happy about having Firefox in the base image. I don't like it to be there, also because on how Firefox depends on FFmpeg and a very specific version of FFmpeg which has some limits, and how the rpmOS3 behaves with FFmpeg's substitution of packages, which makes everything a little bit more complex. So I hope personally to be able to move to maybe Firefox and other applications in Flatpaks. I think it would make more sense, but I also understand that at the moment is not something that is probably going to happen for Fedora 40. Maybe it will happen later, but still, it's something I'm thinking about. And even here, I would expect Silverblue to be the first one to move to Flatpaks many applications before we actually do the thing. We are a very small group of people doing this, and also we are active in other parts of Fedora, and we have other daily jobs as well. So in the end, we tend to be a little bit trailing on changes. It's like, oh, we are seeing a very interesting change in Silverblue. Let's see how they are going to implement, how it's going for them. If it's going to be successful for them, then we are also going to do the same thing so that we have a little bit less burden there. So, are there questions?
I was just wondering, what would you say was your biggest challenge in bringing up a new spin? So the change proposal part, I suppose, is kind of planning and sorting out what needs to be done, but then actually implementing it. Were there any big challenges that you faced?
Yeah. So, well, first of all, the change itself, I would say it's mostly three things. One is comms, so effectively groups of things. One is the kickstart for the Spin, and the third one is their rpmOS3 part of the build. Of the three, the most problematic one has been their rpmOS3 part. And the reason is that at the moment, we don't have that many rpmOS3 editions of Fedora, so the process is not really very documented. It's also not very straightforward. I think that we did changes on 3 or 4 different Git repos to actually get those images properly built and tagged and shipped, as you would imagine them to be. While, for instance, Kickstarter, it was just one file in one repo done. Well, and one reference to that file, but in the same repo, and that's it. So effectively, that part was a little bit more complex. Also because at the moment there are some, I think there are 5 artifacts that are delivered as rpmOS3. Some of them are built in a certain way, others are built in a different way. So it was not that easy to just say, oh, let's pick how IoT is done and then do the same, because actually IoT is slightly different. So we ended up picking, I think, Kinoid, copying what they were doing, and then trying a couple of times to make things working properly.
Cool. Maybe just like a slightly simpler question. I have used Sway on Fedora, but it wasn't from the Spin. Does it ship then with some like basic key mappings to like pull up like different applications, or is it just the default ones?
It's just the default ones, in the sense that we have thought about doing also the configurations, sway configuration, way bar configuration and so on is very, very close to the upstream ones. We have thought about changing them much, and then we decided not to, mostly because we did not have good ideas on how to improve them. So it was like, well, if we get someone from the Fedora UI UX team that tells us, oh, you should do this and that, okay, we can do that. But we are engineers, so not the best kind of people to make those decisions. And also, I think that the reality is that 99-point-something% of Sway users will have their own configurations.
That was going to be my follow-up. I think most people just pull that in and...
Yeah.
Yeah, because it's highly personal, like to each developer, yeah.
Yeah, and that is also the reason why we're at the beginning thinking about providing a version, mostly in the Sericea part, the rpmOS 3 part, without any application, or very close to it. Because the idea was, since everyone wanted a different terminal, a different image view and so on, why should we make a choice? Can't we just ship something that the base part works for everyone, and then everyone can build on top of it? Then we decided to be a little bit more user-friendly than that, but still, it's fairly easy to put your own applications. And for instance, for me, it was a new thing, IMV. I used to use Fe, but in reality, they are so similar that I moved to IMV fairly quickly. Okay.
Thank you, Fabio.
Thank you. There are also a bunch of links here, and I will upload the slides on Sched so that you can click stuff.
Oh, I didn't know I was waiting for someone to do an introduction, or do I start? All right, okay, that makes it easier.
Do you want this video? Because video people can go home if we don't, but if you want a video, we can.
I mean, ideally, people can join from outside, but since this was just approved on Friday and I just announced it today, I think the odds of someone actually watching it are going to be relatively low.
Would you like to go home?
I don't mind.
Yeah, all right, let's keep it then, I guess.
Okay. But yeah, like I said, I mean, I poked a few specific people and I announced it, but that was a couple hours ago, so it's early enough in North America still that.
Amy was going to be like, oh, I need to go tell them in group 7 that they don't need the video. Wait. Anyways.
Okay.
Continue without my interruptions.
No worries. Okay, so this is going to be incredibly informal. I have a couple of slides, but the idea behind this is mostly to get some like-minded people in the same room and talk about what we're trying to do, and hopefully move from there. So some of this is also around SIGs. We've been trying to a combination of reviving some old SIGs, creating some new ones. Because a lot of the old AI and machine learning SIGs were activityless. So we were trying to revive some of that. There's been recently a renewed effort to try and get the heterogeneous compute stuff in Fedora. In particular, there's momentum around the AMD's ROCm stack. There's question of whether that should be the same SIG, whether it shouldn't be. Sorry, because this was just accepted on Friday. I did not have a whole lot of time to prepare. Something there's, like I said, that's going on is ROCm. We've got several packages approved. I'm not sure we're going to hit it before. I don't think we're going to finish before Fedora 39 branches. But I'm always up for being surprised in that area. One of the targets is to have enough of ROCm so that we can have accelerated PyTorch running on Fedora. And I think there's some other work being done on particularly Blender to try and get Blender's functionality for accelerators working with AMD hardware. There are some very early plans around trying to get PyTorch packaged in Fedora. It's early enough that the few things that need to be done are mostly in the Fedora discourse instance. Like one thing I wanted to get, I don't know if anyone here has feedback for. There's been some discussion on how to do communication. I requested a matrix channel, an IRC. Given the number of people who have chatted in that, it's either not known or nobody wanted it in the first place. I'm unclear. Does anyone have any thoughts on, is matrix even something people still want? I mean, there's no one in IRC either. It's just it's dead and has been.
It's being recorded. I'll call out Red Hatters anyways, right? So there are people at Red Hat who have Fedora accounts that are involved in Fedora, there's an internal Slack AI channel that people post on, where they could just post this stuff on the public one or in either the chat or I have been, gently nudging for a while. I don't know. I think more gently nudging would help.
But I mean, that's for the internal stuff. I don't think everyone here is.
I don't mind there being an internal thing, but a lot of that internal stuff could be brought out to there, and I think that will help. And then once that will make it not feel dead, and then people will feel like it's a place to be. But other people who are not Red Hatters, I'm not blaming you. If you are a Red Hatter who should be called out here, yeah,
I don't,
whatever. I
other
don't
than
think
the two of us, I don't
Yeah,
think
no.
I see anyone who's been a regular
Yeah,
on the
so,
AI Slack channel.
But yeah, I will then drop my mic and let somebody else respond.
No, it seems like a lot of silence, so it's either people don't care a whole lot or, I mean, there's no violent objection. One of the things that honestly, I didn't come up with it. I don't remember who did, of Fedora being a duocracy. You know, it's only going to happen if you put boots on the ground and actually do it, and if no one stops you, then it gets done.
Robin or Paul.
Yeah, that sounds that sounds like something I think Robin would say, but yeah, like I said, I remember hearing it from somewhere, but it's been long enough, I don't remember where. So I guess we'll just kind of keep going with that. The other one has been a bit around, and this is some of a larger discussion around mailing list versus discourse. I think the current plan is to get rid of the mailing list that isn't being used and just kind of keep things on discourse, because that seems to be the direction things are heading in, regardless of what anyone feels about mailing lists. There are practicalities involved that I think had really pushed me that direction. It's the maintenance burden of Mailman on the infra folks. So if there's no thoughts, there seems to be more activity on discourse than there is in Matrix, at least for the AIML stuff. One of the other things that I didn't make a slide for it. So how many folks are interested in more of the AIML stuff versus the heterogeneous compute? And anyone the other way around, more interested in the more like the accelerated blender, that kind of stuff? Or not just ROCm, like Intel's One API would fit into that as well. There has been some question around whether they should be the same SIG or different SIGs. So I'm just trying to get information for that. I don't know who would lead, who's going to, well, that's always the question, is who's going to put the time into running all of it. I don't think we have an answer for that, but the voices who most wanted to see them separate are not able to be here. So the silence in this room does not necessarily make consensus.
To me, I don't really care as long as it's functioning. I just
Yeah.
don't want there to be two small groups that are like, oh, we can never have enough people. And then if they would just like,
yep.
Oh, sorry. Yeah, I don't really care. I just don't want there to be two small groups that are never able to find a time where they can both get together, never find enough people to do anything, when if everybody would make one combined group, there would be better.
Yeah, and so there's just more, I think, a little more discussion to be had, because there was one person in particular who wanted to see them separate, and I don't think anyone else cared, so it's going to be, honestly, I think it's going to be up on him. If he wants to lead a separate group, then I'm not going to stop him. Let's see. Just more stuff of, are there other things that folks are interested in? These are the things that came to my mind first in terms of, both the AI, machine learning, and the heterogeneous compute. Some of the stuff is close than others. One API is, quite frankly, a ways away from being packageable in Fedora. There's stuff that needs to happen upstream before that's something that could even go into the repos. So that's further out. Like I said, ROCm, hopefully we will have enough to run PyTorch on by the time Fedora 40 releases, at least at the rate we're going. And PyTorch is an ongoing discussion. There is quite a bit of work to be done there in terms of dependency packaging, in terms of questions around how we can do it, what we can support, whether we like it or not. NVIDIA is the 800-pound gorilla when it comes to the scientific computing. But the way they license their software, it's not something we can distribute in the Fedora repos. So, can we build things in such a way that you could just install part of it from like RPM Fusion, or have directions so that you could download and do it yourself? there are a lot of these questions that have not been answered yet. They're kind of on the list of stuff to do for PyTorch.
Do you know how far off the driver, open source driver they released was supposed to be GPU computing focused?
Yeah.
It
depends on which part. My experience with working with NVIDIA Stack for AIML, the driver's not the problem. The biggest hurdle that I've always had is the CUDNN, the neural network specific stuff that's built on top of CUDA. That has the most stringent requirements on, you have to have, some range version of GCC, some range version of glibc and all that kind of stuff, where I don't think I've ever, the times I've looked at it, you can't find those in the same release of Fedora that's currently supported, if that makes any sense. So the problem with like PyTorch and whatnot on NVIDIA, in Fedora, it's not the driver part, it's the it's the CUDA to a certain extent, but the CUDNN stuff that's built, that's the neural network specific stuff that's built on top of CUDA. Does that answer part of your question? So, okay.
was thinking, some of this stuff is possible. You could ship that. Here's a container or a container from somewhere.
Someone
the
had
driver is probably harder to deal with that way.
I mean, there are ways, relatively simple ways people can install the closed source drivers on Fedora. Someone had responded to one of the discourse posts recently that like there used to be a way to do it. So basically, something called NVIDIA Docker, or Docker NVIDIA, I don't remember which way it was, but basically it was a mechanism through which you could expose the GPU to the container, and then you could have all of the proprietary stuff with all of the pinned versions of things you need in the container, and run that on a system that just had the NVIDIA binary driver installed. We can't really do Docker and Fedora anymore, so that stopped working, but there is a new project that is more generic that should be able to work with Podman as far as I know. So that is, as far as I know, someone is working on it, but I don't know all the details. So hopefully that's coming, that will be a way to do it. Are there other things that fit into AIML, the heterogeneous compute, that people are interested in? Other than the stuff that I've kind of been talking about, these are the things I know of, but just because I don't know about it doesn't mean it doesn't exist.
This is a general question. Do we have
wait for the, can you wait? Wait for the room.
Do we have an objective defined for the SIG, or is this the discovery phase of it?
More the discovery phase.
More
it's something that, like I said, it's a combination of revival and creating. The old SIGs were dead. We're trying to create something new that either replaces or repurposes existing SIGs. So effectively, no. I mean, other than what I've talked about, trying to get PyTorch to the point where at least it can be accelerated on Fedora without having to go to binary blobs. Mm-hmm. So getting to start off at least with RockM.
I think it will really help if we have an objective that can evolve over a period of time, right? So if we have an objective, then you can attract more people. It need not be set in stone. It can evolve, right? So that's one thing. The other thing that I was interested, I mean, this again goes back to the offline conversation that we had about the infrastructure for testing some of these stuff. So you want to bring that up, or?
I mean, there's still a lot of questions. One of the things that has become pretty obvious as we're working to package RockM is that it needs to be tested in an automated way. It's going to be somewhat fragile enough that trying to do all of it manually is not going to end well, at least not for my sanity. So there is an open question on how we can test that stuff. Whether technically there is an AMD GPU available in Amazon's cloud that they may or may not allow us access to. I had problems getting to it personally.
You talked to David?
Huh?
You talked to David Duncan?
No.
He's here with
Okay. Like I said, I don't know. Like I said, I was very irritated with how difficult it was for me on my personal account to get access to the instance with the AMD GPUs, and there's still an open question of whether it's good enough for ROCm, because it's several generations old and isn't on AMD's official support list for ROCm.
I thought I saw one that was newer and
just AMD. They have brand new NVIDIA stuff.
No, there was a newer.
Oh, really?
Yeah, I can't remember which one it was offhand though, and I'm too tired.
So I thought it was like the V520 is the one that they have. I thought, which is like old Navi.
Yeah, it was much larger numbers than that, but I don't remember the details. Okay. But David Duncan is here from Amazon, and if anybody can hook us up, it's him.
Okay. I mean, if we can do this cloud, that would be much easier than anything else I can think of, because the rest of it, like I said, there are open questions on, what system we would use to test it. My first thought is OpenQA. If we do that, is there room, in the racks that they use in Virginia for Fedora Infra? Is there funding for the machines that our GPUs would be in? Can we get the GPUs to test with? Is this a good good route to go? There's a lot of open questions that I don't have answers to.
I think the other thing, for kind of connecting this to your list of what other things that people are interested in, I note that Matt Hicks is interested in the OpenShift data science Kubernetes GPU computing thing, and so having Fedora provide a good experience that ties in with Kubernetes and the cloud for doing computing would probably be helpful in terms of getting positive attention from our large sponsor to us. Not that everything's about Red Hat, just that that's a nicely aligned thing right there.
Yeah. Well, I mean, and speaking sheerly from a pragmatic point of view, yes, I do work for Red Hat. I don't know anything more than what we're talking about. Is if you want to get funding for something, appeal to a sponsor that has money.
Yeah. Going completely the other direction, a thing I think is interesting is was it microtorch stuff that Peter Robinson was talking about, which is basically building the models that will then run on ESP32 or a really tiny microprocessor. And I think that having Fedora be an interesting development environment for that would be cool, because I can see cases where I would I would like to be able to recognize whether it's a cat or a human going up and down the stairs at night and not turn the light on for the cat because the cat doesn't need it, but the humans do. And that would be kind of a fun little project that probably could fit in that with some sensor data. Anyways, but also is probably also of zero interest to Red Hat, but would be cool.
I mean, there's some other interesting things that Peter brought up on discussion or on discourse about some of the OpenCL stuff and trying to get it to run on new hardware, especially some of the ARch64 things. But I think for the moment, like I said, I think the immediate focus is ROCm, because in terms of stuff that we can realistically do in a short period of time, that is it. It'd be great if OpenCL stuff works in the future for acceleration. It'd be great if we can get NVIDIA stuff to work. It'd be great if we can get Intel stuff to work. But in terms of the stuff that is probably okay license-wise with Fedora, that probably works, that we can get done in a reasonable amount of time, we're looking at ROCm for the acceleration, and then probably PyTorch on top of that.
About the OpenCL, it should be already supported, but I'm not sure how usable that is for AI and acceleration.
I was talking specifically about, there was a conversation on Discourse about an OpenCL backend for PyTorch, which there was an experimental one, there was some other support, but it's not anything that is, there were performance issues, there were maintenance issues. So OpenCL aside, it was that specific backend for PyTorch. I'm sorry, I didn't elaborate on what I meant. Well, I think we only have a couple of minutes left. If no one has, I'm going to pass the microphone over to Jeff.
Thanks. As far as hardware for ROCm, is it an extensive list of GPUs that are supported?
I wish I had a good answer to that question. So I will answer it with what I know. AMD's officially published documentation on the GPUs that support ROCm, there are 3 or 4 of them, all of which are over $2,000. There are other lists I've seen. I know you don't only, like, that's just their list. I know one of the other guys who's working on packaging just got a 7600. I think it was one of the lowest end of the current gen AMD graphics cards. I know you can run on other stuff. I don't know what the official things are. Some stuff works, some stuff doesn't. So, long answer, I don't really know. I wish there was a better list. But from what I understand, AMD fully intends to have it work on the stuff going forward. So the 7000 series, the current 7000 series of AMD GPUs, and going forward, I imagine ROCm will work on. In addition to what it already works on, but especially going forward. Any other questions, comments before we wrap up? Okay, well, if folks are certainly interested in this, please keep an eye on discourse. Feel free to ask questions in Matrix. If you have other questions or want to talk about other things, we have a couple more days. Feel free to come talk to me. Other than that, yeah, I think that's pretty much it. Thank you all for showing up and adding input.